All right, so hello everyone. My name is Viraj, and today we'll be having our post-contest discussion for Codeforces Round 991, that is Division 3. All right, so I hope you guys had a fun contest. Relatively, it always happens that Div 3, Div 4 contests have the last problems are pretty much on a very unique data structure, something like that. So that's okay. Uh, so Vatsal, this is the post-contest discussion for today's contest. I think many new students are not aware. So this is something we have when we complete a contest on the platform. We have this code, chef code versus lead code and so. Okay. So first of all, let me have a quick overview. How many of you guys are new in this whole batch? Joining for the first time, the PCD? Because I think this link is pretty much private. So I think this is for everyone, right? I don't think anybody new is joining. Oh, sorry, anybody old is joining us. Okay, so I'll just give you a quick brief, first of all, that this is post-contest discussion. This is going to happen, by the way, for you guys every time. This is like a private link you are going to get before this goes out to YouTube. So that's the benefit of joining TLE. One more of the many benefits of joining TLE. Okay, we solve a contest, and then some mentor like me is going to help you get a grasp on all the problems on a brief level. Yeah, okay. Let me just see if I can mute other people right now. Okay. Yeah. Yeah. Okay, great. So, first things first, of course, let me just quickly have an overview for all the people who might watch this out on YouTube later on. What is TLE 12 batch? TLE 12 batch is our flagship competitive programming course with all 4 levels that helps you go about the journey on competitive programming. This covers mostly all the topics that we see in competitive level, and this is all up to you to explore what is your current level and opt out for an amazing flagship course, all for a very good range. And this is our 12th batch this time. We have been big and bigger than before, and yeah, that is all about TLE 12 batch. So do check this out. And yeah, so all PCDs are uploaded on YouTube, Shreyas. But exclusively Code Chef, Code Forces, all these PCDs are live to you guys first, and then they are uploaded later on. So that is a plus point you guys get. And we try to get you out the PCDs privately 1 hour within the contest is over, so that you have like half an hour to 1 hour to upsolve the problems on your own. And then if you have any doubts, you finally come to us. Okay, great. So we'll be solving all problems today. Okay, there were 7 problems. All right, so let's start quickly. I'll be opening the first problem. Okay, so Coetzee has a text S consisting of n words made up of Latin letters. He also has 2 strips on which he must write the text. The first strip can hold m characters, while the second can hold as many as needed. Coetzee must choose a number x and write the first x words from S on the first strip, while all the remaining words are written on the other. To save space, the words are written without gaps, but each word must be written on one strip only. So since space on the second strip is very valuable, Coetzee asks you to choose the maximum possible number x, as that all the words from S1 to Sx fit on this first strip of length m. Okay, so let us quickly generalize this problem and see what is happening over here. So very simple. You will be given n words. Let me just mute everybody. Do I have the option over here? Yeah. Okay. So generalizing this problem, what do we start off with? We say there are n strings that are given to us. Okay. Basically, these are n words that are given to you. So let's say there is some word 1, there is some word 2, and so on. You have the last word, let's say word n. Now there are basically 2 strips. This is like strip 1, and then there is a strip 2. Now strip 1 can have as many as strip 2, sorry, can have as many as number of characters you want to put. So basically, let's say you write this word 1 on the first strip, or any strip basically, Whenever you write it, what will happen is, let's say this word is Viraj. So let's say you write Viraj. So basically you can say that on the first strip, I have utilized 5 characters. Yes, I can say that. Similarly, let's say the next word is there, something like, let's say Devansh. Okay. So what will happen is if I write the next word directly, what will happen is I want to write this like Devansh, like this. And then I will take up the next, let's say, how many? 7 spaces. So this is going to start filling up strip 1. All right. Now, strip 1 has a limit. The number of characters you can write on this strip is basically M. I cannot write more than M letters. So let's say that I was only allowed to write, let's say, 6 letters. So what will happen is after I have actually written 6 letters on, like I have actually written the word Viraj on this, I cannot write the next word Devansh. Why? Because I want to write Devansh as a full word. I just cannot say, okay, Viraj has already used up 5 letters and then Devansh is of 7 letters. So let's break Devansh and only consume the D. No, I cannot do that part. I will have to write, or I would prefer to write Devansh as a whole part because I don't want to break this guy's name, right? Makes sense? Now, since I don't want to break this guy's name, I will say that from now on, I will have to necessarily write all the rest over words on this strip, that is strip 2, which of course means that strip 2 has infinite limit of letters you can write on this. So this is what I want to do. This is what I want to simulate. Pick up the words and write it on strip 1. As soon as you exhaust total of M letters as a total length of letters you could have written on the strip, pause there and start writing the next letters on strip 2. Now, what is being said is this N is given to you, the strings that are there. All these words are also given to you. And this M is also given to you. That is, let's say 10, I can write 10 letters on the first strip, 12 letters on the first strip, X letters on the first strip. It's given to you. What is asked is, I want to know how many words as full words can I pick up starting from the top, or basically from the left, or like in this case, I have drawn the words like this: word 1, word 2, word 3, so on till the very bottom. So how many words can you actually go pick up till a limit where you will have to stop? Like in this case, if I take an example and I said M is basically 6, so I would have to stop after the first word, that is Viraj. After that, I would have to keep all the other words, let's say Devansh and so on, so on, so on strip 2. So my answer will become 1, that you can basically write one full word from the top on this strip 1, and then all the other word has to go to strip 2. Okay, is this clear, guys? Any doubts? Any doubts? So let us see like a quick example. Let's say I'm talking about like this. This is, I think, pretty much good. So let's say on the first strip, you can write maximum 12 letters. So you can write this hello because hello has 5 letters. Great. Then you will be consuming 5 letters. So now you have a space of 7 letters left on that strip. Next, you can write word also because word also has 5 letters and 5 is still less than 7. So great, write word. And then after that, you cannot write and because and has 3 letters, but you only have space left for 2, which means the maximum letters you could have written, maximum words you could have written on that strip would have been basically 2. So that is why I printed 2 as my answer. Yes, cool enough? Any doubts, guys? Clear? Okay. So very, very simple. Like as I was explaining the problem, I think you got the whole idea. And that is presumably right because this is the first problem of Div 3. So it's expected to be very, very easy. All we can do over here is very, very simple. Just run a for loop. I'll have an answer variable, let's say, or preferably in the problem it was says X. So I'll just take X equals to 0. And then I'll run a for loop from 1 to n. That is basically going to every word. Then what do I want to do? Imagine this. Obviously, I have this strip. It has M spaces that are currently there, which is the M letter spaces which I'm trying to fill. So currently, I can simply say, okay, if M is greater than equal to my current words, let's say word of I dot size. Yes, the size of this word. Why? Because whatever is the total length of this word right now, if it's lesser than whatever is M right now, that is whatever are spaces left with me right now, then I can definitely write this word. Yes. So let's say M is 12 and I want to write a word which is a 5 letter, then yes, I can write it. 1, 2, 3, 4, 5. Great, good to go. You still have spaces left. But as soon as like, and if you think this is right, by the way, so what you can do if this if condition is true, you can just decrement M by word of I dot size. Great. And then you go to the else part and you say, oh, I don't have sufficient M as of now. Great. Break, because you know this is the place you want to stop. So you have decremented M and you have incremented X because you do count that word to be written on that strip. And as soon as M goes below the general limit where you cannot write that word fully anymore, break it out of your loop and you will picture that. Finally, if I print out X, that's my answer. Any problem, guys? Any problem in the pseudocode? Let's look at the code part quickly. Okay, very, very simple. I'll take the T variable, take the N and M, vector of string, take the input. Then I have X. I go in the for loop. If I feel M is greater than the current size of this word, decrement it, X plus plus, else I simply break and I print X. Okay. Now, what is the time complexity? Now, these are very small things that you might not be very aware of right now. That is why I want to print it. You might think that this is very beginner thing. Why am I telling this? But this is very, very important because there are a few things I want to share. Okay. So first of all, what do you think is the time complexity right now? Like you are running this N loop, right? So this is N, right? So you might think that the complexity of this for loop is N. Am I correct? That is not true. What happens is you should remember, imagine this thing, that string also is sort of a continuous memory segment. So when you actually input a string, it is kind of dependent on the fact that you would have to input character by character. Very, very important. How many of you guys knew this? So let's say you are inputting a of I, or you are actually printing even a of I, you are printing to the console character by character. So technically, you do require some more time for that. Make sense? Okay, Devansh got it. N into size of, correct, Devansh. That's right. Ankush, makes sense. So technically this should be, if let's say N is the total number of words I have and M is the maximum number of characters that can be there. Okay, so so M is something that is not right and bother. This N is 50 and S, yeah, correct. Length of S of I does not exceed 10. So basically, I can have a 10 complexity here also, which means this is basically N into 10. Or to be very specific, if N is the highest limit 50, so this is basically 50 into 10. So that into 10 also has to come. Now, this is not a very big thing, right? Even if you don't consider this 10, you are still within your boundaries of time complexity. But this should make sense. You should remember this, because what would happen is if you attempt problems which are far higher rated than this, or problems which have very good constraints, then this might be a problem. Small time complexities are going to make a big difference. And then this should be made aware to you that strings also take up some time. Okay, then you have an N loop. Then this is pretty much constant. Taking out the size is pretty much constant. Okay, please show full code. Okay, this is the full code. That's it. This is the full code. And then if you, let's say M is greater than equal to a dot size, great. And then I subtract it, X plus plus break. So I can say that my overall time complexity is pretty much like, if this N loop runs, so this is like N only, right? But typically this is like N into 10. That is the higher limit on this. Or to be very specific, this becomes O of 500. Because if you have the maximum number of words, that is 50, and S is 10, every word is very large, O of 500. What is space? Space also becomes O of 500 because the vector has the size of N, and then inside that every string would have a size of 10. Okay, clear, guys? I hope this should be clear. Let's move on. Next problem. Close this up. Okay, so definitely a very fun problem. How many of you did solve this problem?
It was a little confusing. I wasn't able to solve it.
Okay, great. So I'll try to give you some intuition. Okay. So let's see this. You're given an array A of length n. In one operation, you can pick up an index I from 2 to n minus 1 inclusive. And then you do the following actions. Either you decrease A of I by 1 and then increase A of I plus 1 by 1, or you decrease A of I minus I plus 1 by 1 and decrease A of I minus 1 by 1. Now, after each operation, all values must be non-negative. Can you make all the elements equal after any number of operations? Okay. Actually implemented A using prefix sum of string, and yeah, that's fine. That's fine with them. Not an issue. I mean, definitely a bit complex, but it's okay. Okay, great. Let us see this. So you have an n-sized array. given to you. Let's say the elements are A1, A2, A3, A4. I'll actually take up a bigger thing. A1, A2. Now what is given is you can do this basically. You pick up some index, let's say I, and this ith index, the previous to this and the next to this is something you can do or operate on. And what is that operation? Either you make the previous go down by 1 and the next go up by 1, that is +1 over here and -1 over here, or you make the previous go up by 1 +1 and the next go down by -1. So this is what is given, that pick like I -1 index, I +1 index basically have +1 plus or minus, or they have minus or plus. These are like the two operations. Now, there is no limit on this. That is very important. It's nowhere given that when I'm performing these operations, do I have to stay in some limit of the number of operations I perform? No. That is one thing to note. So when I was reading this problem, one thing was inside my head, okay, I can do this any number of times. So that's a clue. That's a clue that's hinting me towards what is the other argument. And then the other thing is over here that the question was, can you make all the elements equal? So I basically want to make all these elements equal, so on. Okay, great. So that is my target. Now, what was my intuition? I think the problem is clear with everyone. Should we see some case to understand this? You guys want a case?
It's clear.
Clear. Okay, great. So let's assume directly go to the intuition. So let's say what happened was when I was reading this problem, A1, A2, A3, A4, A5, A6, so on. AN. So first things first, let's say you did an operation. अभी के लिए भूल जाते हैं. Let's forget that. Where did you do this operation? How did you do this operation? Let's say you did an operation. There is exactly one thing that remains constant. Right now, if let's say the sum of the array is S, then do you think this sum will change after you perform an operation? So
No,
Keshav
it
is saying
won't.
does Codeforces always have one-based indexing? No, that is not true. Depends on the problem. Okay. And they have picked up indexes from 2 to n minus 1. What is wrong in that, Keshav? So I think it's clear. Yeah. So sum remains same. Very, very important thing, right? And why does it remain same? Because effectively, if you are subtracting from one place, you are adding on to one place. And you both are subtracting and adding 1. So overall, the sum doesn't change. I do a -1, I do a +1. Oh, fine. The elements might change, but the sum doesn't change. This is one thing. So this was my first observation that, okay, sum is not changing. Second observation was when I said, okay, let whatever is happening, let it happen. What happens, whatever is happening, what elements are it affecting? Let's see. So let's say let's say A1 is a guy who is very grumpy right now and he wants to change. So when A1 wants to change, A1 can only change. Will A1 changing also affect A3? Yes. Yes, it will. Okay, great. So if I took a pen and I said, okay, myself, okay, if A1 is a grumpy guy and this guy needs to change, I'm not right now bothering with what values are finally achieved. It doesn't matter. What I'm right now thinking is A1 is, let's say, a grumpy person. He has to change. He doesn't like his value. I'm changing it. If I want to change A1, A3 will also change because A3 is kind of binded with it. Yes or no? Yes, guys, in the chat. Now, let's say A3 is the grumpy guy. Let's say A3 is the grumpy guy. Then A3 to change A3, either A1 changes, that's already chained up, or A5 changes. Because to change A3, you will have to pick up this A4. And then this is the previous, this is the next. So, okay, fine. A3 has changed. A3 is the grumpy guy. And I was able to change him. I'm not talking about plus, minus, whatever happens. Let's not bother with that. But it will change now. Now, what about the other thing? Let's say you are saying that, okay, I have the next guys as over here, A7, so on, so on, so on. So if let's say A5 is the grumpy guy and he wants to change, then either I have to chain it with A3 or I chain it with A7. So this is what put me to thinking that, okay, I can see that all the grumpy people are kind of connected to each other. As in, I can say that all the indices which are at 2 differences are kind of connected, because the same ideology is followed with A2, A4, A6, and so on also. If A2 is the grumpy guy and he wants to change, A4 will have to change, A6 will have to change, and so on, so on, so on. These are kind of all connected with each other. So all blues are connected, all yellows are connected. Is this true or not? Yes. Makes sense? So this was my second observation, that there is a connection. There is a connection, specifically between odd places and even places. Okay. Operation always applies on the same. Main observation is operation always applies on same parity. Same parity? No, that's not. Oh, achha, okay. Same. Yeah, okay. Yeah, correct. That is what I said, right? Odd places or even places. Vinay. That's true, right? Basically, like all the odd places and even places are kind of in a chain. So you can say that operations are only getting applied on all odds or all with the same parity. And same goes for all even. Okay. So I think this is clear. Parity, good question. So Divya, parity is actually, it's like a CP term. It's used to represent the phenomena or the nature of a number being odd or even. So let's say the number is odd, then you can say the parity of this number is odd. The nature of being odd or even is called parity. Okay, great. So this is my second observation. Now it was pretty much clear that jo bhi ho raha hai, whatever is being cooked up, it's only being cooked up in the odd places and in the even places. So this got clear. Next observation, final observation was, okay, I have some value, so I'll just focus on right now A1, A3, A5, A7, A9, so on, so on, so on, all the odd places. Now, let's say right now their sum is something like SO, that is sum of odd places. So let's say this sum is right now. Now, of course, by the same logic that now these guys are chained up, the values, the total sum of odd places, sum of odd placed numbers, is this going to change? Same logic by observation one. If the total sum is not changing individually, this sum is also connected. So it is also not changing. Same thing. Exactly, Abhinav. So I can say that the odd sum and the even sum, similarly, the odd and even sum, both are kind of fixed. They are constant. So what can happen maximum is this sum can only distribute itself in these locations. That's all it can do. Let's say the total sum right now is 10. And this sum became, because of, let's say 1 was there, then let's say 5 was here, then let's say 3 was here, let's say 1 was here, and 1 was here. So let's say this total sum, I think, is it giving me? No, this is not giving me. Were the values possibly? Yeah, so I can maybe take this sum as 11. So let's say this sum can only distribute itself. That is all that is going to happen. This should make sense, right? This makes sense? This sum can distribute itself. So this sum 11 cannot change overall as a constant. It can only distribute itself. So maybe this 3 goes down, 1 comes up, overall sum still remains 11. So. This is going to happen. Yes or no in the chat? And what is my target? Of course, I want to make, if I want to make all the elements in the array equal, that means individually, of course, I want to make A1 equal to A3 equal to A5 equal to A7 equal to A9. That has to happen. Yes. So if this sum is, let's say, some S value, SO value, then this SO value has to distribute equally to all these places or not? Yes. So simple condition becomes is, if I'm able to get SO, then SO should be distributed equally in all these places. Same goes for if I get some SE, that is sum of even places, sum of even placed numbers, then SE should also distribute itself equally among A2, A4, A6, and so on. That is my second condition. So I can write these conditions. First condition is SO distributes equally. SE also distributes equally. And what's the third condition? After you have distributed them, then their individually value should be same. So let's say you distributed, let's say SO got distributed at these 5. Let's say this was 10. Okay. And SO had to be distributed. So what will you distribute? If there are 5 places, you will distribute 2, 2, 2, 2, and 2. Yes. So this is the distribution that is done for SO. Similarly, you could have distributed with SE. SE got distributed in some way. After the distribution has been done, if they can be distributed and both conditions are true, third condition is obvious. I know A1 became equal to A3, so on, so on, so on, and A2 became equal to A6 and so on. But A1, A2, A3 all have to be equal, right? So how do I check that? I simply say that after the distribution has been checked, done, just make sure that they are also equally आपस में. They are also equally one to one another. So equal to one another. Now, if all these three conditions become true, then the answer is yes. That means yes, something can be done, and I can print a yes. If any one of them fail, the answer is no. Does this make sense, guys? So this was pretty much obvious from the test cases also. They have given you a lot of cases for you to get this intuition. Okay. Manya, is this clear? So like a fun
Yes.
observation. Right. Let's go to the code part. Very, very simple.
I have a doubt.
Yeah, Ketan, ask.
I was thinking that what if the average of even parity or odd parity becomes a float, not an integer? So what we could
That's
do?
an issue, right? Then you cannot
Yeah.
distribute them.
Okay. Sure.
That is what I would check over here. So what I've done over here is I take the input of the array, then I first calculate some odd and some even. How do I do that? Simply I go to the indexes. So now again, I think I showed you the example with A1, A2, so on till AN, but actually the array is starting with A0. So you can understand that part very clearly. If I is 0, 2, 4, so on, then you add to some even, else you add to some odd.
Okay,
How
yeah.
can you prove that if you make all elements equal? Okay, so Shreyas is asking, how do we prove this? Vatsal is asking, can you repeat one case? Okay, great. So I'll actually give you a small idea of the proof. So let's say this was A1, A2, A3, A4, A5, not A1, A3, A5, A7, and A9. And the sum that you want to distribute is 10. Right now, the numbers look like 1, 4, 3, 1, 1. Okay. This is what currently it looks like. Yes. So what do we actually want? We actually want that every sum, first of all, becomes 2. Yes, Shreyas. How do you check that? Because you know that you had total of sum as 10 and you have 5 elements, so it's distributable. It's not currently made, but it's distributable. Yes, Shreyas? Make sense? Distributable to hai? Correct? Okay. Now, what can I do is, I can say, okay, it's distributable and technically it should become 2. So this should be 2, this should be 2, this should be 2, this should be 2, this should be 2. So let's just start from the very front and let's just tell, okay, this element right now is 1. It needs to go up. Yes? So it does it, if it needs to go up, all right, fine. Let me take this is a grumpy guy. This guy needs to become 2. He is 1 right now. This is a grumpy person. Let's take the next guy. And because this wants to increase, the next guy will obviously have to decrease. Fine. Let us decrease this guy. This becomes 3. This becomes 2. Now, is this grumpy anymore? No, this guy's done. Let's move on. This guy. Oh, this is grumpy. He is 3 right now. He wants to be 2. For that, he wants to decrease. So the next element might increase. Fine. This becomes 4 and this becomes 2. Not grumpy now. Now let's go to this guy. He's grumpy. He wants to decrease 2 times because he wants to become 2. So the next element will have to increase 2 times. So this becomes 3 and this becomes 2. And now let's go to this guy. Oh, he's grumpy. He wants to become 2, became 2. And then the last element automatically became 2. So can you see what happened over here? Can you see from left to right, the sum somehow distributed itself? And if you focus that you make 2 every time, you kind of pushed all the sum to the very end of the array, and then finally it became 2. Makes sense, Shreyas? Because it's kind of like imagine that you had a basket of flowers and you're distributing 2 to 2 everywhere. So at the very end, starting from left to right, you will be left with 2 flowers. That's obvious. Okay. So this is the small proof. Now you have the sum even, you have the sum odd. Great. Now I have calculated odd places. That is basically because I wanted to check how many number of places do I have in the odd locations. Odd locations are basically n by 2. Why? Imagine this. Let's say there are total size of the array is 3. Then 3 by 2 by integer division would be 1. And you know you have only one place odd, that is the index 1. And what about the even places? Even places is not n by 2 directly. It is n plus 1 by 2. Why? Because what can happen is, let's say n is 4. So 4 plus 1 by 2 will give you 5 by 2, that is 2 only, which is fine because for a 4-sized array, you will only have 2 even locations at 0 and at the index 2. But if let's say the n is 5, then this will become 5 plus 1 by 2, that is 6 by 2, that is 3, which would make sense because for a 5-sized array, you have 3 even locations, 0, 2, and also the index 4, because for a 5-sized array, the last index will be 4. So this is to accommodate that thing. This is basically called, yeah, exactly. Somebody has written this n by 2 plus n mod 2, or this is basically called sealing n by 2 value. So you could have written n by 2 seal. That is also the same thing. We just want to capture that extra one thing, however you do that. Now, simple, the distribution that happens. How do I get that? First of all, I need to make sure that distribution is possible. So I think, Ketan, you asked this, right? How do I check that? The sum odd, that is the odd sum that I have, and the odd places, that is the count of odd places I have. Odd places should divide the sum odd. If it doesn't, then it doesn't make sense. I cannot distribute. So fine. If it does divide, then this should be true. Sum odd mod odd places equal 0. Same distribution should be true for sum even. And then if both are actually true, then after you actually divide them, their individual distributed value should be also equal. That is, sum odd by odd places should be equal to sum even by even places. Now, all these 3 things, if are true, then you get yes. Yeah, that's very true, Nitin. Good observation. You can write even places directly as n minus odd places. That would also work. N minus odd places. That also works. Okay. Expected rating. I think I should say 900. 900 would be fine.
I had a slightly different approach. I want to check if that's right or not.
Yeah, tell me.
So instead of like breaking into even and odd parity, so
Mhm.
we can claim that the final state that we want to achieve is when all of the elements are equal to the average, if that is attainable. Like if
Equal to
it's
the average.
so if it's distributable, then we want every element to be average in the final state. And so
Mhm.
what we can do is either we start from the beginning or from the end. So let's say we start from the beginning, then we make each element equal to average. Like we can decide on the number of operations that we want.
Yeah, that also works.
So finally, we can check if like after doing this up until the second last element, if the last element is also equal to average, then we can say yes.
Makes sense. Makes sense. So this is like a very brute approach, right? You go to the first element and you try, like what I showed you actually, right? Okay, if the guy is grumpy, you make him, but you have actually done this, right?
Mhm.
So that's okay. That's also fine.
Do we also have to check from the last if we do not get this from the first, like from the
No, no,
beginning?
no, no, no. I think from the first, because the sum is getting like it's getting shifted from one location to the other location, right? So
Mhm.
it's just basically accumulating at the right hand side if you start from the left. So it's fine. If it was not able to fulfill anything on the right, then the same will happen on the left if it's not there on the right. So we don't need to make sure that if it did not work from left, it might work from right. No, if it did not work from left, it will not going to work from right.
All right, got it.
Got it? So Nitin, what he's saying is he talked about taking the average. So like effectively, if you like when you distributed everything, if you distributed all the like sum by this distribution that you made, finally the element that is going to, let's say, okay, so let's say I'll talk about this. This is a yes case, right? So what's the total sum? 10, this is 8, 9, and then this is 6, 15. So can you see 15 by 5 is 3? If I directly take the sum is 15, you do it by 5, that is 3. Effectively, all the numbers have to become 3, and that is true. So it's basically talking about an approach where we consider the average now. Okay, but for that, we'll have to brute out because we need to check what we do. So the thing that I showed you over here, that if the guy is grumpy, you make him +1 or -1, you will have to brute it out. It's a lengthier approach to visualize, but then it works if the average is right. I think you got an AC on this, right? Paras?
No, actually, I had some implementation issues. So
Yeah, we cannot. So, Rakib, what will happen is then the simulation would be in such a way that if you're standing at some ith index, then you consider the I+2 index, right? Because that is the guy who from which you would be taking the value from. Ayush used the same. Yeah, so you guys will get an AC. That makes sense. That's not an issue. Okay. So again, the point is that why I did this is because I have actually seen a lot of problems myself which do this, what I've showed you. The whole idea over here to accumulate a chain on the odd and even places is something that I have seen a lot of in Code 7 Codeforces question. That's why my experience directly intuited me towards this approach. So I would also like this. This is like 2 approaches now for you to explore. Okay, you can explore the average approach after the PCD. AC means accepted solution. Last one condition sum odd by. Okay, so Dhruv, I showed you 3 conditions over here, right? First of all, you want distribution to work, and then the third condition is equal, like the distribution after it's done should also be equal amongst each other, right? So that is why I'm checking the last condition. After you distribute, how do you distribute? Sum odd by odd places is the distribution you would have done on the odd location. Even sum even by even place would be the distribution you did at the even location. If both of them are equal, then that's clear. Then that works. So all third conditions also work. Dhruv, clear?
Hi, Viraj.
Yeah,
Can
Nathan.
you- So if you go to the second last example, 31213.
Mm-hmm.
So if we average it out, it is around, it is 2, I think, 6, 7, 8, 9, 10, 2.
Correct.
But
So
it is
that is why I said, that is why I said, Nitin, I did not say if the average by 2 is going to be divisible, then you directly print yes. Then I
Mhm.
said you will have to simulate the process. So it's basically like what will happen is you know you would want to make it 2. Yes, ideally you would want to make it 2. But to
Okay.
make it 2, you will have to check whether you can make it 2 or not. So he will simulate the process. He will say, okay, let's go to this 3. He's the grumpy guy. Let's make it 2. If I want to make it 2, I will have to decrement it by 1 and increment this guy by 1. So this becomes 3, so on, so on, so on. So this is the thing that you're going to do. And at the very end, you will be left with these 2 locations. Jisme tum chhedkani, this is the locations you will not be able to hamper, because to
Mhm.
hamper some grumpy guy, you need the next to next location from the left hand side if you're going. Okay, so this is like the simulation. Don't confuse this. Don't get yourself confused in visualization. This is like this is a very tedious solution, I should say. Okay,
Okay.
clear? While making it 2, the number becomes negative, answer is no. I mean, yeah, okay. You can keep a check for that also. It doesn't really matter, but fine. At the very end, when the sum gets accumulated, you want twos to be at the very end. It's not going to happen in this case. So yeah, not ideal. Okay, cool. So I think a lot of discussion, very small problem. Let's move on quickly. Yeah, just a second. Time complexity. So very, very simple. Nothing big deal over here. N order over here to check, N order over here to calculate the sum, and then everything is pretty much constant. So time complexity becomes O of N, and space complexity also becomes O of N. I think no problems in this part. Problem C. Okay, so very, very good problem. I should like mathematics was involved, but not a big part in this. Okay, so you're given a number n with a length of no more than 10 raised to 5. You can perform the following operation any number of times. Choose one of its digit, square it, and replace the original digit with the result. The result must be a digit. That is, if you choose x and then you replace it with x square should also be a digit that is basically less than 10. Now, is it possible to obtain a number that is divisible by 9? Okay. So let's try to generalize this very, very quickly. So you will be given basically the number n. Now, the problem over here is like was one thing I can just quickly discuss. You might think that you take the input directly, but read this line. This line should be very, very clear. And this happens a lot of time in Codeforces problems. This number n is very large because the length of this number is in 10 power 5 order. So 10 power 5 order means it's basically 10 raised to 5. So like you can understand that you have 10 power 5 zeros after it. So this is very, very large. That means this is not a normal number which you see in like integer or long values. This is a very large value. Hence, we will have to take this number as a string format, not a number format. This is very important. Okay. Is this clear, guys? Any beginner who might not get this? So Tanmay, what I checked in the last condition was that after you have done the distribution for odd and even, that distributed number should also be equal amongst each other, right? You did some distribution in odd place, you did some distribution in even place. That is after you divided that. After division, both those values should also match, right? Because if A1, A3, A7, all them become equal, A2, A4, A6, all them become equal, that's fine. But aapas mein also they need to be equal, right? A2 also has to be equal to A1 and so on, so on, so on. So that is the condition I checked there. Okay. Great. So I think this is clear. Now, in this problem, coming back, so you will be given this n number, which is of course very, very large. So what I can do is I can represent this number as like digits. So like this is like the n number and this is like the digits that is as d1, d2, D3, so on, so on, so on, so on, so on, a lot of digits. Now, what is happening is we want to make this number divisible by 9. Currently, it might not be divisible by 9, could be divisible by 9, doesn't matter. What is allowed is you can actually choose one of its digit and square it. So let's say there's a digit 3, I square it, it becomes 9. There's a digit 2, I square it, it becomes 4. But the problem is that if you replace the original digit, like when you're replacing the digit, it should still be a digit. So let's say the digit is actually 4, you square it, it becomes 16. Not possible. 16 is not a digit. 16 is, of course, greater than 10. Similarly, other. So that is the thing I can replace, but I don't want to replace it without a digit. Now I want to make it divisible by 9. So first of all, when we look at this problem, and if you look at the cases are very big. Like this is a very big problem. This is very big. It might become intuitive to look at the sample cases and understand. That's why this problem requires what is classically called as, first of all, make up some observations on your own and then try to reason. So even before we start with this very, very important, like solving this problem, there is a very important thing that everyone should know. Jiske bina this problem is very, very tough. That is, if you are trying to divide by 9, you should know the divisibility test for 9. Am I wrong? Does this make sense? If I don't know the divisibility test for 9, can this be solved? No. So now I'm a very forgetful guy. I'll quickly Google this up. Divisibility test of 9 is basically when the sum of digits is divisible by 9. This is the divisibility test. Great. So I just Googled this up. I got it. Great. Now let's move on. So now if the sum of the digits has to be divisible by 9, this is my first observation. Great. By Google. Google help me. Thank you, Google. Next thing. If I am trying to make the sum divisible by 9, that means right now it might happen that the sum is not divisible by 9. Fine. Now, if the sum is not divisible by 9, that means sum of digits modulo 9 must be some value x, which is greater than 0. If it was 0, then it's fine. It's divisible. But if it's greater than 0, that means there is some remainder that is left. Does everyone agree? There is some remainder that is left. Now, understand that this is a very small trick over here. And like, I'll take this over here in new page. Tell me, when the operation that has been given to you, will it increase the sum of digits or will it decrease the sum of digits? Let's say you take up a number, digit, you square it up. Your overall sum will increase. Yes. Can you make your sum go lower? No, it will always increase. Fine, makes sense. So if the sum always increases, then I know that I am trying to and right now, let's say sum of digits modulo 9 gave me x, which means that the current number was, let's say the current number, whatever is this number n, this n number was x larger than the just closer 9 factor. Yes or no? Can I say something like this? This number n was x larger than the closest sum. So there was some number before n, which was actually divisible by 9. And then this current number n was actually x larger. You added x to this before number. That is why when you got n, that is why when you did n mod 9, you got this x value. Does this make sense? Very simple mathematics, right? I'm just taking like a very elementary mathematics. Yes. So now understand this, since you only have the capability to increase the overall sum, that means the x thing, this x value which I want to cover is not exactly x, it is 9 minus x. Because if right now from the previous factor, if it's larger than x, then from the closer next factor, it's lesser than 9 minus x. This should make sense. Yes. Make sense? Okay. So this is the whole idea. So I want to cover this 9 minus x of a difference. Somehow I want to make sure that if I'm able to cover this 9 minus x difference, so whatever this value comes up, let's say 3, 4, 5, so on, whatever, somehow I want to make this difference go away. So Ankit, I'll repeat this. Let's say that right now, let's say, okay, so I have a number. Let's say the number is 21. Now, when you take a mod with 9, what happens? It gives you 3. 9 mod, this gives you 3. Yes. Now, you can only increase 21. You cannot decrease 21 as a number n. Yes, Ankit? So, if you want to increase it and you want to make it divisible by 9, can you say that the next number that is divisible by 9 is 27. So basically, I want to cover a difference of 9 minus this 3, that is 6. And I can see that 27 minus 21 is 6. So can I say that the difference I want to cover is actually 9 minus 6? Or to be very specific, it is 9 minus n mod 9. Make sense? Guys, any issues? Okay, great. Now, added to this, there is one more thing. You will have to put a mod 9 outside also. Why? Just for a example check. Or maybe I'll cover this later on. Okay, so I think this is clear. 9 minus n mod 9 is something I want to cover. So this is the thing that I want to cover. Okay, fine.
Yeah, and
Now,
mod 9 may be 0, na? That's
yeah,
why.
exactly, Nathan. So, okay. So now let's think this. Now that 9 minus n mod 9 is something I want to cover. Now I want to cover how? Understand this. Let's say this value is actually, let's say 9. Let's say this value is 9. Okay, not 9 exactly. Let's not take 9. Let's say this is 8. Yeah, let's say this is 8. So basically, whatever your number currently is, if somehow you're able to add 8 more to n overall as sum of digits, are you good to go? Yes?
Yes.
Okay. Now, let's come back. The digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. If I square up 4, I get 16. Not possible. And because aage numbers are greater than 4, of course, the squaring of this is also not going to work. So I cannot, first of all, operate on these digits. This is one thing. Other thing is, if I operate on, like now if you say, okay, then the green light is for 1, 2, and 3. Can I operate on 1, 2, and 3? Answer is yes, of course you can. But even inside this, if you operate on 1, what will happen? What's the square of 1? It's 1. Does it help you? No. The sum still remains as it is because initially your sum would have been contributed with the digit 1. Right now the digit is still 1. Kuch help hui? Did you get something out of it? No, we did not get anything out of it. That means the only guys that are helping me are 2 and 3. Only these guys can help me grow the sum or increase the sum. No other digit is actually going to help me. So that means if I have to cover this difference of 8, somehow I have to do something like this, that, or if let's say this difference is something like, I'll keep this in a variable. Let's say this variable is, let's say y. So what I want to do is somehow I want 2a plus 3b equals to y. Yes, somehow I want to make some 2's squared up, some 3's squared up, and that would finally help me cover this difference y. Make sense?
I have a doubt
guys?
here.
Yeah, Abhinav.
What if instead of like if the remainder is 8, what if we get 17, like the next multiple of 9?
You cannot
Wouldn't
get
that
17 as a
also
remainder.
work?
So you cannot get 17 as a remainder. Like, so,
No,
how do you?
how,
Yeah.
no, like we have 8,
Hmm.
but suppose we are not able to make up 8 with 2a plus 3b, but we are able to make 17. Then also it should work, no?
So you wanted to catch up a remainder of 8, but you were not able to make up 8 and you were able to make up 17. First of all, so how would you make up a, okay, so like how would that help? How would you, if you make up of 17, how does that help?
Not just 17, like any multiple of 9, if we are able to make, not just the immediate next one.
So 17 is not an immediate next multiple of 8, right? It's 16.
No, like we have a remainder of 1 plus if we add 17, it'll be 18. No?
So you got a remainder of 1 over here. Yeah, I mean, this value is 1. That is what you're saying? Yes?
Yeah, n%, yeah, n mod 9 is 1.
Okay.
So we need 8 more to get to the 9
Correct.
divisible by 9.
Yes.
But if we can also have 17 more to be divisible by 9.
How is that true? Okay. Let me just, I think I'm getting a bit confused. Let's say, let's take an example. Let's say your current value is 19, right? 19 wanted 8 more to become 27, but you add 17 to this. So this becomes 6 and 3. So you basically add 17, that is, okay, now I got it. Great, fine. So
Not
now,
just 17, any multiple in
yeah, I
further.
get the part. I get the part. So the argument over here is, just give me a second. So guys, give me 2 minutes. I think I'll have to relocate. Just okay, guys, am I audible?
Yes.
Okay, fine, cool. So sorry for this. I had to relocate. Yeah. So coming back. So who asked this, by the way? I think I forgot.
I asked.
Okay, so Abhinav, let me continue. And I think we'll come back to this idea at the very end because you might get confused what I would tell next. Okay. First of all, do you agree with this thing right now, what we discussed? So this, let's say this, whatever why this difference is, that's a later point, what that difference is, what do we have to cover? The point is this difference cannot be 17 because later I'll come to that part. It won't be in 17, but okay, I get the argument. You have to cover something over here. Now to cover this, when we say that we want to cover it, what we mean is somehow we want to solve this linear equation. Is this true or not? Does everyone get this part?
Sorry, Viraj, can you please explain how do you derive this equation?
So what I'm saying is, Ankush, basically, like why am I getting this equation is, I'm saying the only 2 digits possible for you to increment your sum are 2 and 3, right? Okay.
Okay.
Now, I think, sorry, this is, by the way, I think this is something wrong. This is, I think, 6b.
Okay, now I got it.
Yeah, cool. So yeah, corrected. My bad. Thank you for pointing me out. So the idea would be, if let's say you take up some digit that is 2 and you square it up, you get 4. Overall, compared to your original sum, how much have you increased? You have increased 2. So can you say that 1, 2 helps you increment your sum by 2? Similarly, if you take up a 3 and you would have squared it up, you get a sum of 9, which creates larger sum as compared to the previous by a difference of 6. Because 3, initially it was plus 3, now it's plus 9. So you covered 6 more. That is why a 3 is going to help you get total number of, like, increment of 6. Make sense? So what I can do is I can say that initially, let's say I had some count of 2. So let's say C2. I had some value that is count of 2s. Then I had some count of 3s. Yes, I had overall some count of 2s. I had overall some count of 3s. What do I want to solve? I want to solve and I want to say that, okay, you need somehow to pick up a number of 2s and some b number of 3s, such that a is less than equal to C2, b is less than equal to C3. This condition is satisfied. And this will help you overall increment your sum by 2a plus 6b, which will cover this y difference. Make sense? Could you please explain the 6 and the 6b part? So I'm saying over here is, if you take up a 3, if let's say you take up a 3 and you square it up, you increment your overall sum by 6. So basically taking a 3 helps you cover a difference of, covers you a sum of 6. Taking a 2 helps you cover a difference of only 2. So if I take a number of 2s, b number of 3s, then I will total gather 2a plus 6b sum, which if is equal to y, then I know I am covering y, which is what I wanted to do. Make sense, guys? Clear? Yes, Abhinav, I think this is clear. Okay. This should be clear with everyone. All right. Tell me in the chat. I will repeat this again. Okay. So now what was left in the problem is I somehow, now I have C2 number of 2s, I have C3 number of 2s. I somehow want to solve this linear equation. So the best way to solve this linear equation was, what I can do is I can run. So this is, again, this is mathematics. I'll show you over here. Equation is 2a plus 3b equals to y. So I can run a loop from 0 to C3, which would make the current variable, running current variable as b, which means how many 3s do you choose? From 0 to C3, you have either you choose 0 3s, either you choose 1 3, either you choose 2 3s, 3 3s, 4 3s, so on, so on, so on. You choose all C3 3s. So this outer for loops becomes a parameter, that is this b, which is the iteration that is running from 0 to C3. So basically now I am looking at all the possible values of what b could have been. Now, if b right now is a value, I chose b to be some value, then all I need to do is somehow solve. Yeah, that's what I did. Never them. Okay, we need to solve that equation of that. Exactly. So what I want to do, make it even, since 9 won't change anything. So 6 and multiple of 2, it's equivalent to subtracting 2. So I subtract the max of 6. Oh, okay. I get the idea. Okay. Fine. So, I mean, this was the general brute error. The point is that this question could have bruted out since you only have 10 power 5 order. So this is working fine. Okay. But yeah, that's definitely a smart thing. So I think this is going to be much more clearer to more people. So what we'll do is we'll say, okay, now iterate from 0 to C3. If you have taken up, let's say, whatever is the current number of Bs, current number of 3s you have taken, that is B value. How do you now make your current y? Y, of course, will be updated. Y will be gone down. Yeah.
It must be 6, right? 2a plus 6b equal to y.
I'm so sorry. I'm doing this many times, right? This is 6. So sorry. 2a plus 6b. Okay, cool. Thank you. Thank you for pointing me out. So now you say how y will definitely decrement. How many number of times? You can say like minus 6b. It will decrement. Yes. When you make this decrement, you need mod 9 again, so that you get the new remainder that is there. Basically, if I have shifted this at this location minus 6b, then I'm taking a mod 9 again. So I'll say, let's take a mod 9. So y becomes y mod 9. Now, what can happen is, if you have decremented y by 6b, y might go negative. If y goes negative, to bring it back to the next possible factor, I will have to increment y 9 again if y is less than 0. This is modular arithmetic. This is subtractive modular arithmetic, which basically governs that, like, if you take a minus b, no, I should not say a minus b. Let's you take r minus l mod m. This is actually equal to, this is not the right way. This is can be written as l mod m minus r mod m plus m, then mod m. So this plus m is actually done to keep the whole thing positive. This is something we actually cover in level 1 of modular arithmetic. So I hope you guys are aware with this part. So we do this next line. I say, okay, y is gone less than 0. Fine. Now I want to solve for an equation that looks like this. Let's say whatever is the new value right now, let's say y dash. So I want to solve this. 2a equals to y dash mod 9. This is something I want to solve. Does this make sense, guys? Now, how do I solve this? This is inverse modulo arithmetic. This is again an advanced topic. Not very advanced either way, but this is the basic point over here is I want to solve for a So if I want to solve for A, I basically want to multiply some M value over here and some M value over here. So like basically I want to make this equation like M into 2A equals to, and this also becomes y dash into M mod 9. And this M value should be a multiplicative inverse of 2. If it is a multiplicative inverse of 2, then this value will effectively become 1. What is multiplicative inverse? Could we just take the map? Could we just take the modulo 9 of the increasing sum of 2s and 6, and then we could find the help of map the target. So where of the point, did you solve this problem? Like, did you get an AC on the solution you are proposing?
No, I did not solve this problem, but I had an intuition that if we take the if we have 2s and 6s, then we take the prefix sums of them, and after modulating it with 9, we could attain a number.
The idea, Weber, over here is you have to explore all the possibilities of taking some 2s and some 3s. Or some 2s and effectively some 2s and some 6s. If you take 2s and 3, that means squaring up, you take 2s and 6. The idea is this. Now, the point over here is what you're saying is kind of greedy. Greedy will not work over here. Because what can happen is, some case you will have to take more 3s, somewhere you have to take more 2s, somewhere you have to take this. So
that is what I'm saying.
by DP, where we, go ahead.
Sir, that is what I'm saying, that if we, in the end, right, we have to take the element which, if we add it to y, then it is it is a, what do I say, divisor of 9, right?
Divisible by 9.
So, yeah, divisible by 9. So if we take, suppose we want 4 2s and 3 6s. So if we store the modulo of both of them, and if we want to find the target element which we want to add with y, then we can just find it by the help of map.
The point is, first of all, the number is a string. How will you take modulo? Tell me this.
We could.
You'll not be
I'm
able
not
to do
able
that,
to explain it, but I think.
No, like you took some 3s and then you said, I will store the modulos with 2s and I'll see what will happen. Yes, this is the line I heard.
So I think in Hindi I could better explain my solution. सर मैं ये कहना चाह रहा था कि अगर 2s हैं और 6s हैं मेरे पास, तो अगर 2s मैंने डिफरेंट नंबर ऑफ 2s है, जैसे 2 then +4 then +6, तो सर उसका मैं अगर मॉड्यूलो 9 कर लेता हूँ और फिर 6 है, then 6 भी इंक्रीजिंग ऑर्डर में 6 12 and then +6 18, उसका भी मॉड्यूलो कर लेता हूँ, तो अगर मुझको 18 प्लस समथिंग चाहिए होगा 2 की जो मल्टीपल है 2 का, तो उनको अगर मैं मॉड्यूलो 9 करूंगा तो उनका जो सम होगा वो y प्लस करके एक 9 ही बनेगा ना जा करके, क्योंकि y प्लस समथिंग उन दोनों का मॉड्यूलो भी 9 के इक्वल ही होगा.
Okay, might work. Like we'll have to cross-verify this with pen and paper formula base, because modular arithmetic is something that is not going to help a lot places. Like if you think modulo right now makes sense, then it might not work, because if modulo rules are getting followed, then this should work. So isko thoda cross-verify karna padega. I did not think this approach. Okay.
All right.
So do ping me up if you feel that works, the approach you're telling. Try to code it up. If you think it works, then let me know. Okay.
Yes. I have a code for this.
Okay, so let's move on. So this is the multiplicative inverse that you want over here.
Viraj,
And multiplicative inverse of 2, basically, like we want multiplicative inverse of 2 with respect to modding with 9. And this is actually 5. Why 5? Because if you do 2 into 5, tell me.
Sorry for disturbing you. I mean, can you please explain me how you reduce this equation 2a plus 6b equal to y? Like you reduced it by y minus 6b. I'm getting this will equal to 2a. So y minus 6b equal to 2a. What is this modulo a?
Modulo a, where am I doing modulo a?
Okay,
this
so it's
modulo 9. Okay. Yeah, so I think brute thing will work. Yes. So I think Tanmay, you got an AC on this. Yeah, that's a brute thing. It's definitely a brute thing. So the idea over here is that, like, why we take such PCDs is we want to tell you the maths behind something, or like not exactly maths. The point is we want to give you some approach which is not very easy, because easy approaches you will get to your own. So Tanmay has actually put up a code, if you guys can see, where you just simply take 2s and 3s and you explore all the possibilities. Some 2s, some 3s, run a loop on both of them, right? Now this is fine. Overall, this is fine. And but the idea would be, how do we solve this with mathematics? That is why I'm trying to tell you the solution. So you like, because I'm trying to introduce you to the world of CP, so you should know these terms, multiplicative inverse and all that part. That's the main idea. That's the main goal. Because after you solve, like after you've understood this problem, or not fully understood, even if I've understood some hints of this problem, you should take this as a homework that you go back and you explore modular arithmetic and multiplicative inverse. That is the idea. Make sense, guys? Okay. So now we want the multiplicative inverse of this, which is actually is 5. Why 5? Because 2 into 5 is actually 10, and 10 mod 9 gives you 1. And that's the definition of any multiplicative inverse, that a number is a multiplicative inverse of the other number if multiplying it and taking mod with the value we wanted to take gives you 1. So this is like, you can Google this directly, what's the multiplicative inverse of 2 with respect to 9, and you will get 5 as an answer. That's the closest value. That's why we can directly now get this. We can say, okay, then the possible A value that was there, solving for A, can be directly calculated as, what is everyone saying? Okay, so Vaibhav, I don't think this is the right thing right now. We are just on the third problem. Let's quickly progress, and I'll take this at the end. Okay. Fine. Okay.
Sorry,
I
again,
think
can
my
you please
board is
explain,
becoming a
like,
bit not clean to look at. Yeah, Ankush, tell me.
Yes, can you please explain the by BR, like where is the role, what is the role of multiplicative inverse?
Yeah. What I'll do is, let's do one thing. Okay, so first of all, I'll just quickly complete this part. Let's say there is an A. Finally, you're able to solve it. Okay, Ankush, let's say you are finally able to solve an A. What do you want to check? Whether this A is less than equal to C2 or not. If this A is less than equal to C2, great. I have found my A and B, solved for A and B, because B was already running from 0 to C3. And the A that I got for some B is also less than C2. That is the total count of 2s I have. So yes, I'll be able to cover this sum. Hence, I print a yes. Else, if I don't do this anytime, I print a no. So now let's do one thing. Let's move on to the code part, because this might become very unclean. And just first of all, see the code. Okay. And then we'll pop up some questions. So very, very simple. I take the string. Then I count the number of 2s, I count the number of 3s, and I count the total sum of digits. That is the overall sum. So I go to every character in S. If it's 2, obviously increment number of 2s. If it's 3, increment number of 3s. And else I increment its value. Now what I'm doing over here is C minus 0. That is, now I am subtracting from the character C the ASCII value of the 0th character. This effectively is going to help me calculate the digit value only. Does this make sense? Yes? Okay. So basically this gives me the sum of the digits. Now, the difference that I have to cover, what is that? 9 minus sum of digits mod 9. This is something I already told. What I was not covering was mod 9 again. Why mod 9 again? Very, very simple. Let's say sum of the digits is 9, or let's say sum of the digits initially is something that's divisible by 9. So sum of digits mod 9 will be 0. This part will be 0. 9 minus 0 will be 9. Now you don't want to cover a difference of 9, because that means basically that is something that has already been covered. So we just take mod 9 again to make it 0, overall 0. So now you know that the difference you wanted to cover was actually 0, which makes sense. So that is why extra mod 9 outside, so that finally your difference to cover is correct. Now you run a for loop from 0 to less than equal to number of 3s. What's the new difference you want to cover? New difference is initial difference minus, if let's say you take up I number of 3s, or let's say I'll make this like B. This is B. If you cover B number of 3s, then you will cover 6 as a sum. How many 6s you will cover? B into 6. So you take difference minus 6L, 6B, mod 9 again. Then if the difference goes less than 0, you again add 9 to it by modular subtractive technique. And then I find the multiplier. How do I find that? That multiplier would be the new difference I want to cover. That is, I showed you over here, y dash into this multiplicative modular inverse, that is 5 multiplicative inverse, and take a mod 9 again. So this is the multiplier. So this is basically A. Now, if this A is actually less than number of 2's, I have solved for a B and A. So the linear equation is solved and I can print a yes. Else, if never this solves for any possible B, then I'll print a no at the very end. So if this solves for yes, I'll print a yes and I'll return. If I return over here, what will happen is I'll come out of this void function, which would mean I would iterate to the next case, which is fine because yes, I have got an answer. Yes, I printed it and fine. Let's move on to the next case. Solved. But if this return statement never executes, that means after coming out of the for loop, I would have printed a no. And that would mean, yes, now I have got everything. Okay, great. Any problem? Any problem with the code, guys?
Calculation of A.
Yeah.
Like how we are calculating.
What I'm saying over here is the calculation was you wanted to solve this. 2A equals to y dash mod 9. Okay. Now to solve this 2, like to solve this A, this 2 should be gone. So you can do this like this. A equals to y dash mod 9 divided by 2. Something like this. Yes?
Yes.
Now what happens over here is that in like, this is mathematics. This is mathematics, which you will have to study. This is only, you'll find good GHG articles also on this and everything. If let's say you do A by B modulo something, okay, then this by B modulo cannot be written. What happens is, this is not right way of representation. We have to, or we do convert this to writing as A mod M into the multiplicative inverse of B. So I put over here, I plug over here the multiplicative inverse of B. So multiplicative MI of B. Let's say that value is X. No, not X. Let's say B dash, something like B dash, P dash, and then I take a mod M. This is theory. Okay, Ankush? That is why when I divide 2 over here to solve for A, when I take mod with 9, I cannot take mod with 9. I will have to take 2. I will have to find the multiplicative inverse of 2 with respect to mod 9, which is actually 5. That is why this 5 value becomes B dash.
Okay. And
rather than dividing it by 2, you multiply this into 5 and 10 take a mod 9.
Okay. And the multiplicative inverse of A.
Exactly.
Like,
so I think somebody has quoted this amazing thing. This is called Fermat's theorem, by the way.
Okay. So so if I want to calculate multiplicative inverse of A, so it will be A M minus 2, right? A M minus 2? Oh, okay. No, so yeah, so that is getting calculated. Yeah, no, it's not A M minus 2. Multiplicative inverse of a number is basically the number which when you multiply it with and you take a mod, you get 1. Okay, so I mean, I'm just stating the Fermat's theorem. So according to it, if I want to calculate the A inverse modulo M, then it will be A M power of M minus 2, right?
Yeah, A M power of M minus 2, correct. That's the Fermat's theorem.
Okay, so it will be 2 to the power of 7 modulo 9.
Yeah.
Okay.
2 to the power of 7 would be, I think 32, 64, 128. And 128 with 7 would be, I think you will get 5 only. Not sure. You can see that. Make sure that you get this idea, okay? Okay. So Keshav, 5 I'm getting is because 2 into 5 is 10 and 10 mod 9 is 1, which is the definition of a multiplicative modular inverse. If I want the multiplicative modular inverse of 2, it should be some number x with which I multiply 2 and take a mod with 9, then I should get 1. So I'm getting that. That's why 5 is a multiplicative inverse of 2 with respect to mod 9. Okay, Keshav? So how do you find it? So Shreyas, it's a Fermat's theorem, which we call it. There's a whole code piece to that. It's a very advanced topic, by the way. So that is why I calculated this in my head, because this is like hit and trial, okay? That I got 5. You can Google it out also, you'll get 5 directly in the contest. But the point is, this is hit and trial. Because this is a very small value. For higher values where let's say the number is very large. Let's say I'll tell you calculate the multiplicative modular inverse of 2 lakh with respect to 1790, something like that, then you will have to run some code piece. And that is called Fermat's theorem. Okay. Yeah, tell me. Somebody was saying something.
I was saying 128 modulo 9 will be 2 itself. Like 2 to the power 7 is 128 if we modulo it by 9. Yeah, it's like it's 2, right? 128 modulo 9 is.
So Ankush, let's do one thing. Fermat theorem is, again, I don't want to discuss Fermat theorem with you. That is not the objective of this PCD. Okay. You get this?
Yeah.
Let's take this at the end. Okay. Or let's take this on Discord. That would be great. Cool.
Yes.
Okay. For now, understand this, that this is how multiplicative modular inverse has to be calculated. Okay. Modular exponentiation where we raise the number of power 2 for modular inverse. Yeah, correct. So that's so again, you will have to give it a thought. I just told you Fermat's theorem, you search it up quickly on Google and then you're trying to understand it quickly. It's not a very easy theorem. Okay.
Actually, I was the part of TLE 3, like level 3.
Oh, okay.
TLE
You were
10.
part of TLE. So then I think we covered it there in TLE 3.
No, actually, previously I was part of it, level 3 and TLE 10 base 10. So I can discuss. I mean, I want to know the
Okay,
code part
fine.
of it.
Then that is
So
what
we
I'm
can
saying.
discuss it
Because
later
the
after
doubt
the
support is open to you. If you, first of all, give it some thought also, what's the Fermat theorem? Because the idea would be, read it once more. You will definitely get it. If something happens, then always pitch up in the doubt support. Okay.
Okay, so I want to discuss it after the
Sure.
after this PC discussion. Can you please
Definitely, we'll do that. This is not right for this class right now. Okay.
Okay,
great. So again, guys, is this part clear of multiplicative modular inverse? How do we get this? Basically, you have to solve for A. Now, you could have done this with the brute force solution, which again is what normally I think many beginners would have done. But then the objective over here is to teach you something new. So now you guys can explore Fermat's theorem, modulo inverse on your own, and that will definitely help you solve high rated problems or even problems that are like this. Because if this idea strikes up, it's also easy to write. Okay. That would not work, Shreyas. That would have a very high time complexity. Because to check whether y is present on the set or not, y would be a very big number. Let's say it's a 10 power 5 order number, so that you cannot check. And there would be a lot of possibilities. Okay, great. So what is the time complexity now? Very, very simple. You are running this in basically n order, which is the size of this, let's say the string s. And then what I'm doing is simple over here. This maximum would be n order again, because it can happen that the all are threes over here. Let's say this number, everything is 3. So this runs in n order. And similarly, anything inside this is pretty much constant. So that would mean overall time complexity turns out to be O of n, where n is the size of the string. And because this is a string, the size will also matter. So O of n again for storing that string. Cool. I think we have understood the problem. Let's move on. Yes, guys. Why didn't we consider the other multiple of 9 other than the immediate? So, Abhinav, do you understand modulo has this technique that you don't need to consider the other multiples of 9 if you have already considered all the multiples of 9 with giving a modulo from 0 to 8, because you've taken a mod 9 again. So you're a kind of in the modulo loop. If it satisfies for something right now, then it will satisfy for the next factor also, and so on, so on, so on, so on. So that is why finding the answers from 0 to 8 is fine. Isn't it O of log 10 of n? No, I'm saying n is the size of this string. Why O of log of n? Keshav, I'm saying n is the size of that string. Storing digit length. Yeah, that's what I'm saying, right? The length of this number is 10 power 5 order. So if let's say this 10 power 5 or whatever order of that length is, if that's n, then that's the length. Okay. N is not the number. I'm so sorry. Okay. I think I should take some other variable then. Let's say this is sz. Sz is the size. Okay. Or not sz. Let's say length. Alien. Fine. Now this is fine. Alien. Cool. So let us move on. Next problem. you are given a string S consisting of digits 0 to 9. In one operation, you can pick any string in the string except for 0 or the leftmost digit and decrease it by 1 and then swap it with the digit left to the picked value. For example, in one operation from the string 1023, you can get 1103 or 1022. Find the lexicographically maximum string. Again, yes, correct. So now, first of all, the question over here is, I think everybody will read the problem and understood it very simply. You just take up a digit and then you decrement it by 1 and then you swap it with the digit left to it. This is something you can do. Now, that digit which you pick up should not be 0 or it should not be the leftmost digit, because if it's the leftmost digit, there is no more left to swap. Yes, makes sense? So I think the problem should be very clear. And that is the example that they're going over here. Let's say you pick up this 2, decrement it by 1, and this becomes 1. Then swap this new 1 with this 0. So you will get 1103. Let's say you take this number. This is 3. 3 minus 1 is 2. Swap this 2 with this 2. Same remains same, 1022. Clear, guys? Okay. Now, the main argument over here was what is lexicographically maximum? If you understand this, this problem is very simple. Lexicographically means how do a word pops up in a dictionary? Everybody knows a dictionary? Yes? So in a dictionary, whichever word comes first is smaller. Whichever word comes farther is larger. So when I say I want something to be lexicographically larger, I want it to be in a dictionary, the largest word. Or not the largest word exactly, not in terms of the size. Whichever word is coming at the very end of the dictionary is larger. Okay. Now, when you apply this logic on this part over here, since the string S is only made up of from 0 to 9, that is the digits. So if I say I want lexicographically largest string, what does that mean? Can I say I want the first positions to have larger numbers, larger digits? Yes. If let's say these are the locations. Let's say this is the S1 character, S2 character, S3 character, S4 character, S5 character, and so on. Do I want, or can I say that I would prefer that S1 is as large as possible? Because from the left, if S1 goes as large as possible, then in the dictionary, this letter is going to go very, very behind, or this will make it more maximum. Make sense? Is this clear? S1 should be as large as possible. Yes, guys, make sense? Okay. Now, when we come over here to the question, what do we understand is, let's say you are standing at some current SI character. Then first of all, this SI character can only move left. Okay, fine, can only move left. Now, would you not prefer that if this SI character is very large, then it should actually move left? You would? Because moving left is obviously helping you, since SI being very big will try to place itself to a position which helps you even large your new string lexicographically. So this becomes a greedy question where we consider an S of I and we say, okay, fine. You stand at this S of I until you feel that this S of I can go left. What is that till you feel condition? Till you feel condition means either you know that going left helps, or you know that this number is currently greater than 0. Both conditions should be satisfied. So if I want to shift it to the left, it should make sense that I make this shift. How does that make sense? If let's say this is S of I, and let's say this is S of I plus 1. Sorry, I can say I minus 1. But why? Because this is like, if this is like 0 base index, 0, 1, 2, 3, 4, and so on, so on, so on. So S of I minus 1 and S of I is there. If S of I wants to jump to this location, of course, when it jumps, S of I will decrement. So when it makes a jump, S of I minus 1 should of course be greater, right? With S of I minus 1. If it's not greater, will this swap make sense? No, this swap doesn't make sense. Yes. And of course, if S of I minus 1 goes less than equal to 0, then also you cannot make the swap. So first of all, this swap should make sense by this condition. And then this condition should also be satisfied, that it should be greater than 0 for to swap, because swapping requires subtracting by 1. And if it's already 0, you cannot subtract it, because same condition except for 0. So this becomes a simple brute force question where you can begin from the very left-hand side. Just go to every S of I and B to look at that guy and say, oh, just move more to the left, keep on moving till you think you can, and stop wherever you think you cannot. Great, good to go. Do this for all S of I, and you are bound to receive the best possible answer, because you have made sure that from the left to right as you move, the larger digits move more to the left-hand side. This is something you have made sure. Yes or no? Does everyone agree? Anybody who's not getting this idea? Very good question, Ujjwal. I actually tell you what is the time complexity. I mean, like I have an estimation on this, but yeah, should work. Okay, so I think this is clear. I hope there are no doubts. Any doubts, guys? Okay, let us move on to our coding part. So I've taken a variable t, that is the test case. I have the string s. Now I have s dot size as the length of the string. What I'm doing over here is, just to make life easier for me and coding easier for me, I will convert this s string individually, every character in that, to a digit, because that will help me to do my calculations. This is just like making my life easier. Else I will have to do a lot of stuff and a lot of C++ based stuff to make sure it happens. Can we sort this taking as a... So Tanmay, you also want to decrease, right? So if you sort, how will you make sure that happens? Oh, okay, S of I minus I. Yeah, might work. But then that custom sort would be, I mean, if I can pull that up, that's fine. It's making it very complex. I mean, the custom sort is still going to work in a complexity that it's that over here is working. So anyways. Okay, so now I converted to the digits. How? S of I minus ask a value of 0 gets me that value. That is 0, 1, 2, so on till 9. Now I run a loop from 1. Why 1? Because of course I have to skip the 0th index, since S0 cannot be changed. S0 is a guy who cannot be shifted more to the left. That's why S0 is something I don't start with. I start with S1. Now I copy that I index and I run a while loop, which is basically that loop which is telling me, till you think S of I has the capability to shift to the left, make it shift to the left. For that, what has to make sure happens? Of course, so copy of I is basically the current index you're running in. So that index has to remain greater than equal to 1. Yes, because as soon as this index reaches 0, you have to stop, because now you cannot move more left. So this is condition 1. Condition 2 is, of course, this digit has to be greater than 0. If it's actually 0, then you cannot decrement it. Okay. And then the other thing is, this digit minus 1 should be greater than the previous digit, or basically this digit greater than previous digit plus 1. So I just shifted this equation. This minus 1 goes at this location. So minus 1 to this location, this becomes plus 1. Now, if all these three conditions are true, then I will make the swap. How do I make the swap? I can copy this value right now. The current value will become the swapped value. And then the previous value will become this value minus 1, because one decrement has also happened. Now, if I feel that this index is still greater than 1, decrement it, because that's the index that I'm running. Else I will break. So this makes me come out of the while loop, because I know either I have reached the last index or whatever has happened, something has gone wrong. So I need to make sure this comes out of the while loop. Okay. Now, if I finally run this for logic, this would happen for all s of I, and then I can simply collect back my string in some variable, and that is what I print. So this is basically how I run a string res, initially empty, start with, like, go to every digit, and then just add on or concat on the res string the converted character of that value in terms of that particular digit. Then simply print it out, you're good to go. Okay, guys, any problem in this? Hello, any problem? Okay, no. Keshav is saying, great. This is my code. Second case is not working. Please share the code. Yeah, of course. All the codes, by the way. So I think everyone is a beginner. You will get this. All these codes are going to be shared in the description of the PCD when it comes out live in YouTube. Okay. That would be, I think, after 2 or 3 more hours, you will get all the codes, will all submissions. Don't worry. Now, what is the time complexity? Very, very interesting. Tell me the time complexity. Any guesses, guys? What do you think is going to happen? O of n. Looks like n square. Yeah, looks like n square as well. It's not n square. So O of n is correct. Yes. Why O of n? To be specific, it's not exactly O of n. We remove a constant factor, 10 into n. Exactly. So understand this, everyone. So I have a loop over here. This runs simply in n order, if n is the size of the string. Now this is running in n. Inside this, you might think that this while loop is also running in n. Why? Because you will think, okay, if I'm standing at some s of I, it might happen that it shifts more to the left and goes up to the very leftmost position. So it basically, this inner while loop also runs in n order, and this becomes n square. Yes, Ujjwal? Or anyone? Does this make sense? Exactly. But if I check over here, the other condition is digit of I is actually decrementing by 1. And you have to stop if it's 0. So a digit can maximum be 9, and it can go maximum till 0. That means this inner while loop will break after you have done at most like 9 to 10 iterations, because after that, that digit cannot be moved any further. So that means this inner iteration is on an order of 10, which means this overall, this becomes in an order of n into 10.
Hello, Viraj.
Yeah, Utkarsh.
I want to ask that in my second test case, I am getting 6701 instead of 6710. What might be the problem in that? I can share my code.
No. Okay, so let me just say now s of 0, k count is less than 9, k is greater than 0, k minus minus. So again, Utkarsh, I think it's should say not a very clean code. So I cannot do a mental dry run on this thing. What we can do is, if you stay back, I'll actually solve this question with you. Great.
Okay.
Or you can discuss this on Discord later. You can send me this code. We'll try to dry run this. Great.
Okay.
So again, guys, all the doubts that you have like this, very welcome. The point is, don't put up a doubt with me where I will have to dry run something, because that takes up a time for all the other people in the chat, right? We have 22 people right now joined with us. So everybody wants to see a lot of questions, and that's the target. Okay, so let's not hold that back. You have the doubt support open for this part. If you have any doubts regarding this approach, then tell me. Yeah, this is brute force, Tanmay. Not every digit will do exactly that. This is brute force. This is brute force. This is basically telling S of I, okay, move till you can. And the problem is, this is working because the movement is maximum restricted to 10 iterations for every S of I. So this works. By copy I minus minus shouldn't be. So I'm going to the previous index, right? S of I moves more to the left. So if you are moving to the left, that means you want to minus minus, right? In the indexes. Enough. Okay. Cool. So time complexity becomes, and space becomes OFN. Great. Can we move on? Next problem. Let's move on. Okay, so you are given three strings A, B, C consisting of lowercase Latin letters. The string C was obtained in the following way. At each step, either string A or string B was randomly chosen, and the first character of the chosen string was removed from it and appended to the end of the string C until one of the strings ran out. After that, the remaining characters of non-empty string were added to the end of C. Then a certain number of characters in the tree were randomly changed. Now, for example, let's say the string is ABRA, BSCADA. Then they have colored coded very nicely. So let's say the string can become something like this, or like this, or like this. So on could be obtained. And you have to tell the minimum number of characters that could have been changed in this string. How many of you guys solved this problem? Great, cool. Exactly. So like this is a very famous problem when it comes to subsequences. Like it's like a LCS sort of a problem based in strings. Okay. And let's try to understand this. So again, I don't need to figure out. So I solved this by recursion plus memo because that could have been easily done in this constraints. If somebody wants tabulation, then that's effectively very, I mean, it's fine. The argument is you solve it anyway how you want. Okay. So I think the problem is clear. Let's actually quickly get this out of the way. You have the string A, you have the string B, and you have the string C. C is basically made up by taking, let's say this is A1, A2, A3, so on letters, B1, B2, B3, so on letters. Just take up letters from the string 1, 1, 1, 1, 1 and append it to the end of C. So let's say A1 goes. So this is A1, then let's say B1, let's say B2, then let's say A2, then let's say so on, so on, so on. Just keep on appending it. And then you might change some letter. So let's say this B1 letter doesn't look like B1 anymore. Basically it becomes some other. Let's say it was letter A, now it became Z. That's a change. So now this change string overall C has been given to you, and you want to determine how many changes were actually made from this original C as compared to this new C that you have gotten. If this is like C old, and after the changes you made a C new, what are the minimum changes that were done? Now, how do we solve this is actually to first of all understand why is the concept, what is this concept that is getting applied and why is it getting applied? The argument over here is that, first of all, we should understand we are wanting to apply 2 pointers in this. Basically, there is there's like a 1 pointer that is standing at this A location, this first location of A, this location at B. And then there is another pointer that is currently at C, which is whatever C string is that is given to you. Now, of course, you might ask that, okay, the current character that I could have taken is A1, the current character I could have taken or is B1, and then the current character I have at this location is some other character. This string is something like C1, C2, C3, C4, so on. So this character is C1. So tell me, guys, what can happen? It can happen that this C1 is actually equal to A1 directly. Either it can happen that this C1 is actually equal to B1. Or it can happen that this C1 is, let's say, not equal to A1. Or it is not equal to B1. These are like some sort of possibilities that can happen. Yes, guys? Do you understand this? If I quote the term that there are possibilities, then the answer is yes. There are, of course, possibilities for this particular C1 to happen. Now, if they are equal, then also you have possibilities. If let's say it is equal to both of them, it can happen, right? C1 is equal to A1 and also equal to B1. Then which should you take? Which character would you have considered? Would you have considered a character in A, or you would have considered a character in B? Who knows? You don't know that. That's a possibility. Same goes for the logic that if let's say they're not equal, you definitely want one more additional cost to be added because now you know the character has been changed, But from where has it been changed? Has it been changed with A or was it changed with B? You don't know. Possibilities. So the idea is, if I was a beginner and I had just read the concept and I look at this problem, now because of this idea, I can understand that, okay, this problem is a DP problem because I am talking about possibilities. So many possibilities that can happen. Because a lot of possibilities can happen, I will have to maintain DP. I cannot do a greedy operation. I cannot make sure this is always true. There's a lot of possibilities to explore. This is going to be a DP problem. Is this clear, guys? This is intuition building. So whenever you look at a DP problem and you don't understand it's a DP problem, ask yourself, are there possibilities? If you think there are possibilities, there's a 90% chance that's a DP problem. Okay, great. So now we have understood this is a DP problem. Now, when it's a DP problem, this is a very classic DP problem of understanding that now all I want to do is to realize there are some, like if I solve this, like how do I solve this? That's the question then. If you know DP, there are basically two famous ways to solve this. Either I do a recursion plus memoization or I do a tabulation format. So that's the two things that are followed in DP. What I will explain over here is recursion plus memoization because it's much easier to imagine. Okay, so we'll discuss recursion and then we'll memorize it later. So very, very simple. I'll say, okay, there's a helper function. This function is going to get called. This, of course, is going to have I and j. I think it would be wrong for me to do this pseudo coding over here. Okay, let's actually look at the code part directly. How about that? Because I'll tell the code over here, then I'll do the same thing over there. Or actually, I'll give you a brief over here only out of a very simple thing. So what do we actually want to do is, we would want to start off like, I would say that, okay, I, that is my pointer with A, and the pointer with B string, that is J, both start with 0. Effectively, both have to reach the end because I want to cover the whole string. But the possibilities are, if let's say I recurs further, then the option right now would be, if I'm standing at I equals to 0, then I can say that, okay, is my current pointer for the string C, let's say that character is C of, let's say something like pos, is this equal to A of I or not? That will create a possibility. If it is equal, I will recur directly. If it's not equal, I would want to recur with a +1th cost. So the possibility of C pos with AI has been done. That is the current position of the character in C compared with the current position in running in A, that is A of I. Same thing I can do for C pos being compared with B of J, sorry. If it is equal, recur directly, do a J+1 call. And if it is not equal, plus, because a cost gets added, and then do a J+1 call. And at the very end, finally, you want to return if you know that both pointers have reached at the end of the strings, respectively A and B simultaneously, and that is going to be your base case for the recursion. And now along every way, you want to minimize, because what do we want to calculate? We want to calculate the minimum characters that have changed. So the possibilities when are being explored should be minimized always. That is why I'll say, okay, fine. Let me try to take a minimum function on this, and whatever possibilities are called, I will take the best out of them. And this is what I will try to return. Is this clear, guys? Standard DP recursive problem. Okay. Clear to everyone? I think this should be clear to everyone. Okay, great. So now let us look at the code part and understand this. Yeah, this is the problem. So what I'll do over here is, seems hard if you haven't seen before. Exactly, that's true. So we'll take the string A, B, and C. Then I'll have the size of A, that is N, size of B, that is M. Then I have a DP, I have a global DP declared over here. And then I will assign everything to be -1. That is the initial state in DP. Total, I have created a DP of N+1, M+1, because I want +1 more indexes. This is just the standard way of proceeding proceeding with one based indexed in DP so that I don't overcross my boundary. Assign is a STL function, Naivedyam, which helps you assign values quickly. So this is like memset for array. How memset works for array, assign works for vectors. So this is a vector of vector, that's why assign. STL function to assign the values or initialize the values in the particular data structure. So I want every value to be -1, hence I'll call this. Okay. Dot resize is also something you could have used. Not a big deal. Now I'll call the helper function. I'll pass 0, 0, that is INJ, and ABC, that is the strings I want. So now this is a very, very important point I'll try to take up over here for any beginner who watches this. And if you guys are not aware, can you see I'm taking A, B, and C as reference type? That is, I'm using AND A, AND B, and AND C. This is done because of the very simple reason that first of all, I don't want to repeat A, B, and C as copies as I go in the recursive tree. Because if I don't pass this by reference and I pass this by value, every time you recurse further, you will create a copy. And that is not correct. That is not beneficial for you because you might run into, okay, somebody pointed it out. Emily, exactly, Abhishek. You might run into memory limit exceeded because you will use a lot of stack space while you recurse. So we want to pass it by reference since this is constant. A, B, and C will not change. So why do I want to make copies of it? If it's constant, never changes, don't make a copy. Let's only take it A, B, and C with AND variable so that it references it out and not passes it by value. So this is the theory thing. Now I have INJ. If I reach simultaneously at the end, I would return 0. If the values has already been calculated of dp of I of j, great. That means dp of I of j has to be returned directly. So dp of I of j not being equal to -1 means return it directly. Then I calculate the pos. What is pos? Pos is the index that runs in C. So this is the position in C. How do I get that position? It's obviously going to be I plus j. Why? Because if I is the number of characters you have already done and dusted, they are already done and dusted, and j is the number of characters that are already been done and dusted, then you must be standing at I plus j location in C. Since overall, the C string is a clubbed length of A and B. Does this make sense, guys? Yes. C has an overall length that is overall total length of A plus B. So C, the current pointer that runs in C can be calculated by a summation of I and j. That is the pointer in I, the pointer in A, pointer in B. Then I have the result variable, that is the current cost. I declare it to be very large, that is 1E9, since I want to minimize this cost. Now, what do I want to say? I want to say, okay, if I is less than A dot size, that means I plus 1 index exists. It's still iterable. So the cost becomes helper. I call the helper function. And then I add to that either a 0 or a 1. I add a 0 if I feel it's not equal. If I add a 1 if it's not equal. I add a 0 if it's equal. Because if it's not equal, that means something was done over here. Some change was done over here. I need to count it. That's basically one extra change in character I need to count. So if it's not equal, that means some change was done. Fine, count it. If it's equal, then this will return 0. So you did not count it. Great. And then minimize this with the cost variable. Now, this is the possibility explored for comparing C pos, that is the character in C, with A. Similar thing to be done with B. Same thing, just recur for helper with I kept constant, but you increment j to be j plus 1 because you have moved further in B. And same condition checked with bj not equal to C pos. Now you return minimum of res and cost. Now, when after all these if conditions, res has become the best possible case that could have been come from all the possibilities, taking C pos considered with AI also and bj also. So at the very end, I can make dp of I of j to be res. So anybody who wants to understand the state transition over here, basically dp of I of j would mean the minimum cost to make, like, okay, the copilot is already helping me, minimum cost to make C from 0 to I plus j minus 1 from the string that has been covered from 0 to I minus 1 and B in the string B covered from 0 to j minus 1. That is the state transition, I and j. Okay. Any problem, guys? So I return this at the very end, and this basically tells me the answer. Nevedam, is the state transition clear to you? So I think now you can tabulate this out. Would be fine. Any issues, guys? Okay, great. So let us quickly move on. Okay. What is the time complexity? Very, very quick. You take the input of the strings, and then this main thing is coming from this helper function, which is running in the multiplication of the states. So I'm running an I pointer, J pointer, and because this is memoized, so the DP is going to be I into J, or basically N into M. So this is 10 power 3, 10 power 3 order. This is 10 power 6 order, which works. So we can say overall time complexity is O of N into M. And space also is O of N into M. T into N into M. So when I'm pitching time complexity, I'm pitching time complexity for every test case, Ujjwal, not for every test. Okay. Great. I hope this is clear. Let's quickly move on. Problem F. Okay, so again, now this problem is a very, I should say, this is a advanced problem. This is something for which you need a grasp of a data structure, which is very advanced. Now, I don't have any time to tell you what, like the internal workings of the data structure. This is something that becomes a homework for you. So anybody who watches this video, we'll actually code that data structure for this so that you're able to understand how do we get this. Main idea is something that we need to understand. And then all you had to do is to somehow calculate it. For that, there's an advanced data structure. So let's read this. You are given an array A of length n q queries. That would be L to R sort of a structure. We want to find the maximum possible M such that all elements AL to AR are equal when done modulo with M. This is something that we want. And then we want to process all these Q queries. So now, first of all, let's understand that what sort of a structure are we looking at? When we talk about AL mod M equal to AL plus 1 mod M, so on, so on, so on, AR mod M. This is something that we want to find. Now, this can be modified. This equation can be modified, and it can be written something like this, that let's say I start taking up two pairs of adjacent equations with, let's say, AL. Then I can write this as that the difference of AL plus 1 minus AL mod M has to be equal to the difference of, let's say, AL plus 2 minus AL plus 1 mod M, so on, so on, so on. Yes, can this equation be modified like this? Agreed? Just shifting this equality sign. And this is actually the crux of the problem. From here, we realize that what are we trying to do is, let's say, from a segment that starts with AL and ends on AR, if we create a difference array on this array, then basically, if those differences are D1, D2, D3, D4, so on, so on, so on, we want to find the best possible M in these differences. And to do that, understand this, that now the question is basically, so this is the differences. Now the question is basically, how do you get the best possible difference the best possible M, as in the M that divides all of this. And since when I say best possible M, it means since I'm talking about the largest M, the largest possible M which divides all of this is actually the physical meaning of a very known term in mathematics that is called GCD. What is the greatest possible thing that divides some collection of numbers is called GCD of those numbers. Correct? Am I wrong in this? The greatest possible number that might divide some collection of numbers is called the GCD of those numbers. Yes, agreed everyone? So we somehow want that if after this difference array has been created of every two adjacent numbers, I want to take the GCD of all these numbers. If I'm able to do that, I'm great, I'm good to go. Okay, works. So now the whole argument lies is, how do I get this? So if a beginner sees this problem and understands, let's say, the equation up till here, you might think that I can brute this out. But the problem over here is we cannot. Because if you run in every query, that is, let's say, a while loop, you will have to run a while q minus minus query. And inside this, you will have to take the input of LNR. This is something that is required. This is something you will have to do, because if you don't take the input of LNR, how will you process something? So because of this, you will run into a time complexity that's O of Q. That's already there. Now inside this, let's say somebody says, oh, great, sir, I will run a loop from for of L to R and just process and calculate the GCD. The problem is this loop will run in O of an extra time complexity, which means your overall time complexity will go in n into q order. And that's a problem since n and q both are in 10 by 5 range, which means I need to eliminate this logic that is inside. This outer while logic cannot be eliminated since this is O of Q, and I need to process the queries, but this inside logic can be eliminated. I need something quicker which helps me calculate the GCD of a segment or range. You can say range quickly in a faster time complexity. And this is where the whole idea of a data structure, very good data structure that comes into picture is segment trees. This is the data structure. Now, this is a very advanced data structure, so I would not want to go in the very depth of this. For anybody who watches this, just understand this. Segment trees is basically a data structure which is going to help you process queries faster when it comes to range-based queries. So now this is a range query. You want something to be processed from L to R. In this question specifically, we want to process the GCD from L to R as a range. So this is going to be very helpful with a segment tree. So I can now build a segment tree on this difference array. And to be specific, how does a segment tree work? It answers every query in log of n order, and then into whatever merging complexity is utilized. Now, because you're over here calculating the merging of two nodes as GCD, so that would require another log of the difference of those things again. So I can take this as A of I maximum. So basically, now your segment tree, if you build a segment tree on this difference array, you will be answering every query. That is, what is the GCD from L to R within a time complexity of log n into log of A of I, which is very, very quicker as compared to n. Since log base 2 of n into log base 2 of A of I will work very quick. This would something be like in 10 power 5 order, you take a log base 2, very, very quick, of course. And then, of course, log base 2 of 10 power 9 order is also very, very quick. So definitely, like it would be something like, I think 10 power 5 iterations would be like 30 iterations, and then 10 power 9 order would be like 50 iterations. So like 30 into 50, I think somewhere around what is coming? 13 to 50 is 1500. So like somewhere around like 2000 iterations is something you can say, which you would cover. Now that is fine. That would be like just below 10 power 8 order for you to work with. Of course, that's an estimation, okay? Can this be done using ordered set? I mean, you can do this with sparse table. No, I don't know how you can do this with ordered set. I mean, you need the range GCD, right? So ordered set is never going to give you something as a range. Cool. So I hope this is clear. So
10 raised
now,
to power, sorry for interruption, but 10 raised to power 8 is a very tight complexity.
Yeah, it's a very tight complexity. Yes. So what would happen is like ideally, this should not run with segment tree. This problem should be very, if we would have went very high on the constraints, sparse table would have been the correct thing to use in this data structure, because sparse table improves your time complexity even further. To be very specific, it removes this extra log n factor. So right now it's log n into log n, or log into log basically. Now it will be only log if you use a sparse table. Now, why is that happening is something I don't want to comment, because I don't want to teach sparse table right now. But this still works with segment tree, is why I'm going ahead with segment tree only. Okay, Utkarsh, you can definitely note this term down, sparse tables, and try to explore this on your own. You will understand sparse tables specifically for GCD calculation does this in even faster time complexity as compared to a segment tree. This is part of TLE level 4.
Okay.
Okay. Cool. So now we can directly see the code because this cannot be taught in this overall idea. So this is the segment tree code. This is basically a boilerplate that we use where the merging function is the GCD of the left and right node. Then this is the construction of the segment tree. It's a structure basically. Don't need to go into that part of how does it does. It basically merges the two nodes when it comes from bottom to up and maintains everything in a log n power. And then you can take the main idea. You take n and q, take the array input. Now, if the n is already one, okay, so I think I missed this part. What's given in the question is very, very important over here is if in particular you feel that any m can be taken or m can be infinite, print 0. So when can m be infinite? Very, very simple thing to think over here is if let's say n is 1. If let's say there is only a single number, then a single number will be divisible by a very large number. You can take, let's say I take infinity. Great. It will still be divisible. Yes. Because it will be equal. It's the only number that's there. So I know a single number, let's say a0 mod infinity. It's fine to write. So that is why I cannot print infinity. That's why in their language, we want to print 0. So if n is 1, then every query will have the answer as 0. I hope this is understandable. Yes, any problem? So Ujjwal is saying, okay, so Ujjwal, that is what I'm coming over here. I just covered a simple case. If n is 1, then everything is infinite. So you print 0. I hope this is clear. Yes. Okay. Now, if let's say I go in the else part, I first build the difference array. That is difference. Every difference of I becomes absolute of a of I plus 1 and minus a of I. Then I will build a segment tree on this difference array. So now I have a segment tree available with me. I go to every query. Since L and R are given in one base indexing over here. So first I'll make them 0 base index. How do I do that? L minus minus, R minus minus. Now they are a 0 base indexed. Now I would want to run this difference array. I would want to calculate the GCD in this difference array from L to R minus 1. Why R minus 1? Because if you understand this visualize will be, you understand that, okay, difference array is already of one less size than N. And then I'm also doing one L minus minus, R minus minus. So I want the difference from L to R minus 1. So I make a query on this tree and I get the value. Now comes the main idea, which we were asking. If let's say the GCD is 0, the GCD can be 0, right? So you merge everything and you come out with the GCD 0. If you come out with the GCD 0, what does that indicate? For this given set of numbers, anything could have been taken. Since its GCD is 0, that's the effective meaning of that part. That is why you can keep a check over here to take the infinite condition that if you feel GCD becomes 0, print 0. Else you can print the GCD value. Because then it would be some value, maybe 1, 2, so or whatever is there, not a problem. Okay. Clear, Ujjwal? I hope this is clear with everyone. This is an advanced data structure. So anybody who watches this, pause the video. First, try to explore segment trees a bit on your own, or basically data structures which help you do this range queries on your own, and you will get this whole idea how we are pitching this out. Main idea, first of all, starts with this. Understand that we wanted a difference array just by moving around these equations only. And that difference array wanted to be run in a range query where you got the GCD of that difference array from L to R. To do that, classical complexities would have not worked. Hence, some new data structure was inserted. That was segment trees. So now what's the time complexity? Very, very simple. As I explained, this is Q order, and then this is log n order. But this is exactly like the making query part is going to be log n into, this is going to be log base, like log of A of I order again. So basically this is like, if you take a log square order, something like that, so you can just report the higher time complexity as O of Q into log n into log n again. This is going to be the better time complexity. Of course, you can write the time complexity for building this tree. That would be O of n into log n again. So whatever is the better of these two terms becomes the answer. I can write a plus over here. Why plus? Because this is separate and this is separate. So this is building of the tree and this is squaring of the tree. And space is going to be simply O of n only, because I'm using some space for the array and almost the similar number of node space for the tree. So it's same either way. Like it's not going to be exactly n. The overall space for consumption over here is, of course, increases, but it remains in a definite order where it works. So it's not a problem. Okay, clear guys? Any problem guys? Let me know. Clear. Ujjwal is clear. Got it. Utkarsh got it. Okay. Other people, Manya, Nevedyam, Satyam, Sujul, do you got it? I hope this is clear. Great. So I think this is something you guys can explore. I would love if you do that because this is part of TLE 4 and this is a very important topic because, okay, so Nevedyam, you did not get it completely. Did you not get the idea or did you not get the data structure? If you did not get the data structure, I cannot help you in that part right now because it's a very long data structure to understand. Implementation. Yeah. So then that's definitely, you will be shared, of course, the code. You can explore segment tree first on your own, and then you can actually come back to the code part. You will understand the implementation. It's a very classical implementation that I've taken, and it's something people mostly copy paste. So this is something like already pre-made written, just some changes had to be done in the merge function. And then I can just use this code directly anywhere I want to answer segment trees later on. So it becomes like a template for me to later on use. Okay. And this is very beneficial because advanced concepts are not always written all the time. If we have some templates already, then in this context, it helps. Great. I hope this is clear. Okay. So guys, now just give me 1 minute of time because I think you guys can see my screen share. It's on 4%, my laptop. I'll just quickly bring my charger. Okay. And then we'll continue. Okay, guys, I'm back. So I've done the first 7 problems with segment trees, though still can't get implementation on my own because it takes about an hour to do so. Yeah, I mean, that's the point, right? If you get some template idea, then it's always better. So it's definitely an advanced concept. So it requires practice. I think myself, I took like at least 1 month, 20 to 25 days at least to solve. I solved around, I think 20, 25 problems on that. And so yeah, helps. Okay, fun. Should we move on? I think my quick time has gone. Just a second. Okay, cool. So the final problem, that is problem G. Okay, now this would require some good thought. We'll try to solve first one and then what's the solution if not able to do. Yeah, that's fine. Great. Thank you, Ujjwal. Thank you for joining. Okay, so now again, this is an advanced problem. Same thing, right? This, of course, requires good visualization. And I will try to make some strong cases so that you understand the whole idea. But if anything gets short of course, it's open to comments and chats. Let me know if you think. Okay, so it's a very brief idea I will try to say. because the code might not become very, very clear at a very initial glance. So you will have to dry run something on your own and you will get the idea. I'll actually show you a dry run on a case so that it becomes much more clear. So now tree destruction. Given a tree with n vertices, you can choose two vertices A and B once and remove all the vertices on the path from A to B, including the vertices themselves. If you choose A equals to B, only one vertex is removed. Your task is to find the maximum number of connected components that form after removing the path from the tree. So any beginner who watches this, I'll give you a quick overview of what are the terms over here so that you have something to start off with and then try to explore on your own. Okay. So this is a simple tree problem. First of all, it's talking about a tree. So tree means there are something called as nodes. So we'll build up a small tree like this. I'll take up a case so that it becomes clear. Let's say this is the case I'm taking. Tree means there are some nodes and nodes are connected by some edges. So let's say this is 2, 1, which means there's a connection between 1 and 2. So let's say 1 and 2 all connected. So this is like, sorry, this is 1 and 2. Let's say connection. Then the connection is 1 and 3, 1 and 4. So let's say 1 and 3, 1 and 4. And then 3 and 5, 3 and 6. Okay. So now this is the connection that I've done. What is allowed is you pick up any two nodes that are there. Let's say I pick up something like A, something like B. And from the path that goes from A to B, I remove everything. All the nodes, all the edges, everything is gone. It basically gets deleted. All this is gone. Let's say I picked up this. Now, whatever is left over, in that leftover tree, you have to make or count the connected number of components. Now, what is connected components? Connected components basically means that it has a definition that if a component is of the connected type, then any node U and any node V, both of them are reachable. As in, from U, you can reach V, from V, you can reach U. This is going to be true for all the possible pairs of nodes in that connected component, in that component. So right now, you can imagine that this whole tree is one connected component. Why? Because if you pick up any two nodes, let's say I'll pick up 1, you pick up 5. Is 1 reachable with 5? Yes. From 1, you can go to 5. Great. Let's pick up 3. Let's pick up 4. Is 3 to 4 possible? Yes. Great. So I can see any node to any node is possible. That's why this right now is one connected component. Is this clear, guys? Any problem?
Clear.
Okay. Now, what is given is you do this operation only once, and then you make some new connected components. How and why will that happen? Realize over here. Let's say I do this. I delete this node to a path till 3. Can you see what happened? As soon as I did this, can I say that now this is a separate component, this is a separate component, this is a separate component, this is a separate component. So how many components do I have now? I basically have 4 components. Yes, 4 connected components. So some move that I did made me reach more connected components. That is why the argument is do this in a best possible manner and tell me how do you do this so that you make the best or largest number of connected components. So this move, by the way, that I did for this case was actually the best, since this gives you 4 connected components and that is the answer. I cannot do anything better than 4 in this case. Is this clear? I hope the question should be clear now. Okay. Remove nodes with maximum connections. Yeah, kind of that's the idea. So now when I saw this problem, my main idea over here was this seems a very greedy problem. Why? Is because I know that when I'm trying to remove some node, technically that node should be a node by whose removal I create more number of connected components. This should make sense. Yes. If there is some component, if there is some node that I remove, it should help me create more number of connected components. Yes. So basically this question got divided into 2 parts. I'll give you a very simple thing. So let's say there is a node V. It is connected by a parent S. Okay, or it is basically connected in the top. Now it has some children. Child 1, child 2, child 3, and so on, so on, so on. And these children might have more number of connections. Don't worry. Now same thing over here. This is V connected. Child 1, child 2, child 3, and then they can have more connections. Now, when I saw this problem, why does this idea come to my head is because I thought, okay, whatever is the path, whatever that happens, let's try to first of all make myself aware that, okay, when I'm talking about that path and I'm talking about a node that comes into that path, I'll name that node as V. Now let me focus all my energy that can happen with this V node. So I took this generalized case. This is a very general case. Yes, agreed. There is a node V. It can have some children. It is connected on the top because it can have some parent also. And it has more children further. So this is like a very general diagram I've drawn for this V. Now I thought to myself, okay, what can happen? What are the two things that can happen? I'll draw this with a yellow pen. Either you draw a path which starts somewhere from the bottom, goes to V, and then comes back to some other child or some other subtree in V's children only. This is possibility 1. And possibility 2 is you start somewhere in the children of V, and then you actually don't come back anywhere to the other children of V, you actually go up. So the path, this yellow is actually the path which you want to remove. This either is a path which only explores the children of V, or it explores one side of V and then goes up. Can you think of any other possibility with respect to this node V? Tell me, give this a 2-minute thought. Do you think it's possible for this, the yellow path that might happen to go through V? If it has to go through V, it can only be of these two categories. Either it takes some directions from the children only and remains in the children only, or it goes through one child and goes above V to its parent. Yes? Make sense? So Manya saying yes. Okay. Everything saying yes. Cool. So since these are the only two possibilities, I asked myself, okay, fine. Let's explore these two possibilities together. Sorry, separately. I'll say, okay, let's talk about case number 1. What can happen in case 1? Greedily, if I have to start from some children, some place, some subtree of a children, and then go and end myself on some other subtree of the child, what should be my ideal way of doing it? Of course, let's say this child has 10 more coming out branches. Let's say this has 5, and let's say this has 15. And let's say there was more numbers. I just took like the first 3 numbers. Now tell me, guys, greedily, tell me, if you start your path from C1, go to this node V, and then come to C2. What will happen? Can I say that this structure over here will become a separate connected component? All the other children that we might have will become another connected component because this branch will break off. So because this branch breaks off, this thing as a whole subtree will become a connected component. Similarly, if there was a C4, another connected component, C5, another connected component. Yes. And so remember this, all of this, and if C1 has 10 children coming out of it, all those 10 children will break away. So if C1 is there and it has 10 more children coming out and C1 is totally gone. So all these are separate connected components. Yes, all these 10 children are separate connected components. Yes, guys, make sense? Hello? Yes? So if I understand this, if I ask you starting with C1 and ending to C2, what is the total count of new connected components you get? Your answer will be, let's say this is the only number of edges. Okay, let's say there is a guy C4 over here. Let's just say this is C4. That's all. So can I say the answer would be 10 plus 5 plus this portion. So can I say V1 had total of 4 children? And he had one parent, of course. So this one parent plus 1 plus from 4 children, 2 are gone. 2 children will make another 2 components. So 2. Is this the answer? 10 plus 1 plus, yeah, 10 plus 5 plus 1 plus 2, 18. Yes. Do you understand what is the meaning of everything? Where is 10 coming from? Where is 5 coming from? Where is 1 coming from? Where is 2 coming from? Okay. Now tell me, जो parent है, the parent that is above, I cannot change that parent, right? That parent has to be there. It will give me one component only. Okay. That means this is something that is not touchable. This is, I put a tick over here, it's not touchable. But what is in my hand? Right now, I took an example of C1, C2. Can you not argue that, sir, if I am like the thing that I make over here, this thing is also kind of not controllable, because this thing is basically coming from, let's say the number of children V, this node V has C, then C minus 2 is basically this value. Can you see 4 children? So 4 minus 2, 2 value. This is also not controllable because 2 children are always has to increase. So this is also pretty much constant. These two values are constant, but what is not constant is this children subtree. Is this constant? I took an example of C1 to C2. Can you not take some other example? Can you not say, sir, greedily, can I not take C1 to C3? It's giving me even a higher value. This is giving me 10 plus 15 now. Yes? Yes, is this a wow moment? Do you get this? Okay, so Abhishek Chamka. Correct, exactly. Understood? Yes, makes sense? Okay. So that means it is very, very beneficial for me to do what? If I'm standing at a V node, I would want to prefer, because I know the one parent is still there. Great. The V, this value is actually, let's say the C children count as C minus 2. This value is already there. And cannot be done anything. But these two values, I'll call this MX1 and I'll call this MX2. Why MX1? MX1 means what is the children in this V, for this V node, who has the largest number of sub children. And then MX2 becomes the second best child who has the next largest number of sub children. So this MX1 and MX2 can be the best top 2 contenders, and they can overall give me the best possible case from case number 1. Is this clear, guys? Is case 1 clear?
Yes.
Any problem? Okay, great. Now let's move on to case 2. What happens if your path was not going through children's? It was going through one children and then to V. Now let's say I take over here, this guy has 10 child, this has 5 children, this has 15 children, same thing. And then there's only one child, C4. Okay, so let's actually remove this, same pen. 10, 5, and 15. Now tell me, if you remove V and something beyond V also, let's say something that happens, you basically get how many components? 1, 2, and 3. Which means basically you get how many components? You get C minus 1. Now, can you say 1 plus C minus 2 and C minus 1 is basically the same value? Because 1 plus C minus 2 is also C minus 1. So can you say that this part is still pretty much constant, which you are getting, even in the second case? 1 plus C minus 1. Can imagine it like this. Not exactly like this, but can imagine it like this. But what is that extra control part on which you have the hands, which is, since you removed C1 over here, only 10 was added. You can say, sir, I will not remove C1. I will remove C3 because it has more children. It has 15 children. So C1 makes the better choice. Sorry, C3 will make the better choice, and that gives me 15 children. Yes. So now case 2 is basically saying take only mx1. Are you guys now getting the full problem? What are the two cases and what are the possibility of these two cases giving the answer? Yes. Hello. Okay. So this is the whole idea, right? Now we would want to return this value when we call the DFS call. So this is again a tree problem. So there is DFS that we would be running. DFS again is a technique of traversing on the tree. It's called depth first search. And we would be using this sort of a technique so that we are able to go in the depths of the tree and explore and come back. And when we do that, when we actually return some value, we would want to return this value. Why this value? Because if you are standing at a V node, I'll take this on a new page actually. If you're standing on a V node and you explore the child possibilities, whatever could have happened, then to its parent, that is something I did not draw over here. Let's say this parent S, this parent S. To this S parent, you would want to return the value that comes from here, because that would mean the path started from a child and almost ended at this location. Now this S guy is going to use this value further to build his own case, and so on, so on, so on. So from the bottom, when you reach the leaf and you have gone in the whole depth, you will try to come up and up and up, and you will help return this value so that the next parent, the next super parent, to super parent, to super parent uses that values further. Okay. How many edge length can you remove? There is no restriction. Abhishek. Okay, cool. So now this is a very, I think, so now what I can show you the code directly so that you get the whole idea. Okay, so this, yeah, this is the code. So now, by the way, how do I do this? How do I implement this is a small technique for calculating the children's. So understand this, that everything is dependent on one simple thing. That is the degree of a node. What is degree of a node? Degree of a node is degree of a node is the number of edges that go inside it or that are connected to it. To be specific, it is basically the number of edges that go inside it, but since this is an undirected tree, it's basically connected to it. So now what is happening over here is, if you look at this diagram, I'll come back. Okay, let's draw this again. 1, 2, 3, then you had 4, and then this was 5, and then this was 6. Okay. Okay. So now, if I calculate the degree of these particular nodes, this will be 3. Why? Because there are 3 edges connected to it. I'll do this with a different pen. This is degree 3. Just bear with me. Why am I doing this? This is degree 3. This is degree 3 again. This is degree 1. This is degree 1. This is degree 1. This is degree 1. Now tell me, when we wrote this C minus 2 and 1 and everything, if you talk about this V node, okay, if you talk about this V node, technically, can I say that you are basically trying to say for this particular V node, you are removing 2 edges from it? Kuch bhi ho jaye. Let's say I talk about the first path. In the first path, you remove this edge and you remove this edge. So basically, the number of components that you now received are the degree of V minus 2. Yes, the degree of V minus 2, because the degree right now was this edge, this edge, this edge, this edge, this edge, Okay, I'll do this with a different pen. This edge, this edge, this edge, this edge, and this edge. Now, two edges are removed. So can I say degree minus 2, degree d minus 2 is actually the number of components you create for case 1? Similarly, for case 2, if the path is followed like this, same thing. If the degree right now is 1, 2, 3, 4, 5, you removed this edge and this edge. So now the components you made out were 3. So this answer directly can be written as simply small dot. If there are no limitation number of edges we can remove, can't we get? So, okay, Abhishek, the idea is you can only remove the edges on the path from A to B. And that is only done once time. Okay, so I think you are getting confused. Okay, great. Because either way, then the answer is directly n, right? Then we don't need to solve the problem. You have n nodes, n are the number of components. You will remove everything. Yeah, good to go. Okay. So that is why in the implementation, what we'll do is we first calculate when we have the agency matrix and we have the degree. We run a loop. We get the edges u and v. I create an undirected edge because I want to run an agency from u to v and also v to u back to back. So that means an undirected edge. Push back and then I calculate the degree. So I'll say, okay, the degree of u also increases by 1 because one edge would be going in it. And then degree of v also increases by 1 because one edge is going in it. It's an undirected edge. Now, if n is 1, that means there is only one node. If there is only one node, great. And the answer is 1. I'll return directly. Else, I will calculate the value. Value is each degree minus 2. So for every node from 1 to less than equal to n, value of I becomes its degree minus 2. Now I run a DFS function. The DFS function runs from 1 to negative 1 being the current node and negative 1 is right now what I pass as dummy parent. You can see the function over here. This is again, I'll do it like this. Yeah. This is a function that I have created for the DFS call. Now, this is a type like you might ask, have you seen this function before? Like, have you seen functions like this before? This is called lambda functions. Okay. So lambda functions is something you can explore. This is Manya. This is called lambda functions. It's basically better to create lambda functions because what would happen is if you want to create a DFS call separately outside the void loop, then you would have to pass the agency matrix also. But what happens is a lambda function encapsulates its whatever functionality it has to do within the function itself. So this is the solve function. Inside that, I'm using the lambda function. So great, I can use the agency matrix directly. All I need to pass is u and v. So that's the un parent. Okay. Now, again, this is syntax. So I'm not discussing that, how I've written this. mx1, mx2, as I told you. Then I run a loop, go to every v in the agency of u. If it's not equal to parent, since I don't want to backtrack, this is like no backtrack check. Since I don't want to backtrack in my tree. So I'll say if it's not, then means go even down. Calculate the temp value coming from calling the DFS function again. Now that temp value is actually that value. So if it's greater than mx1, mx1 gets updated and that mx1 becomes mx2. If it's not, else if greater than mx2, mx2 becomes temp. So this if and else if check helps you maintain the top 2 values of the subchildren, which I wanted. Then I have a result variable, by the way, which is long of max. I take maximum with this result and then the possibility of mx1 plus mx2 plus value of u. That is the possibility I told you. And then what do I return? I return back so this is case number 1 covered and case 2 value I return so that later on the super parents can use that condition. So this is case 2 return. Case 2 return condition basically would be take the best child, that would be maximum of mx1 and mx2 plus only the value of u. And this overall helps me get the whole answer. Is this clear, guys? Okay. So now I would highly recommend that you draw this on the test case and you will clearly get the idea why this is happening. Now at the very end, I have done actually one thing more, that is res plus 2. That is, if when I calculate the main result, I'm not printing res, I'm printing res plus 2. This is a very, very important line. And the meaning of this is very simple. Understand this very simply. Initially, I have made all values go minus 2 degree. Yes. Now understand this, that the logic that I showed you over here, for this to happen, can you not argue that this V node has to be of a type which is not leaf. It cannot be a leaf node, right? This V node right now is not a leaf node, right? Because I'm talking about some children. It has some children and so. So basically, get this idea that when you actually consider the whole cases, it might happen that you take up leaf cases, or it will actually happen that you take up leaf cases for which the initial degrees that you subtracted by 2 need to be taken back again. That is why I need to cover that degrees back, because this is something I did for my calculation. This was not actually happening. My actual degrees were not -2. They were actually degrees I only. I made them -2 because it helped me with the component calculation. But overall, they'd have to be added back to the whole answer. So what we can do is quickly, we can get this test case running. Let's say if you calculate now on this cases, the values over here would be written like this. This would actually be 3 minus 1, 3 minus 2, that is 1. This would be -1. This would be -1, -1, -1, and this would be 1. Now what you will do is you will start a call from here. Then you will again make a call down from here. You cannot make a call down from here. So you will return actually 0 over here. Similarly, you will return a 0 from this location also. And from here, you would have returned a 0 from here location. You would have returned a 0 from this location. Then you would have returned a 1 from this location. So now, when you would have finally come out of this whole loop, you would have gotten the best case as 2, which means 2 connected components. Now, it right now, it should mean 4 connected components, because you know that the best case was actually this thing. When you remove, you get 2 straightforward 4 connected components. So to cover that, we have to add 2 back, because the answer should be 2 plus 2, that is 4. And the idea is this leafy thing. Okay, so this is something you can explore. Draw up some more cases. Anybody who watches this, draw up some more cases on your own. Draw all these cases yourself, and you will get the idea. Why am I doing this part? Very, very simple thing. It's basically covering back the degrees which we initially subtracted. Any problem, guys, to visualize this? Cool. So now what is the time complexity on this? It is, of course, the time complexity of a simple DFS call. DFS call runs in n plus m order. That is the number of nodes and edges. So I can write this simply as O of n plus m, where n is the number of nodes, m is the number of edges. Whatever is that in this whole question is what is going to be the time complexity. Similarly, for the space, it's also in the same order for the adjacency matrix. Okay. So I hope I was able to make some sense in this problem. Again, tough problem. Give it some more thought after you end this PCD. So it should be much more clearer. So let me stop my screen share. Thank you everyone for joining. That is all from my side.